This is Mission Control Houston. Pilot Charlie Bolden aboard Discovery reporting that received a message that he did not expect from the Spock or the shuttle portable onboard computer in efforts to call up deorbit ignition times for two contingency primary landing site deorbit opportunities for today and tomorrow. He encountered these unexpected messages, and without his user notes, is looking for a little assistance from the ground to give him some insight to that.
No need to acknowledge Discovery. We're 2 minutes from Teeter's handover.
This is Mission Control Houston. At 2 days, 19 hours, and 16 minutes, the Orbit 1 flight control team has arrived here in Mission Control and completed the handover from the planning shift and are setting about the early morning flight day 4 activities, first of which is an NC3 burn, which is essentially a phase adjust burn designed to arrest the closing rate between Discovery and the Hubble Space Telescope. Discovery is currently about 42 nautical miles from the Hubble Space Telescope and closing at a rate of 1.7 nautical miles per orbit. The NC3 phase adjust burn will change the velocity of the vehicle at a amount of about a half foot per second, which should eventually arrest the rate of closure between Discovery and the Hubble Space Telescope and set up 40 nautical mile station keeping once again while we stand by for confirmation from the stock that the Hubble Space Telescope aperture door has been successfully closed.
This is Hubble Telescope Control in Greenbelt. We have verification now from the Space Telescope Operations Control Center operators that the aperture door procedure to close the aperture door as a preventative measure has been completed. At one time, just a few minutes ago, the aperture door was partially open to about 1.76 degrees with no preload on the aperture door hinge torque tubes. If the aperture door would have been commanded in its current, or in its position that it was current, to be fully open, then it would be hitting the top end of its door at an unacceptable speed. So the idea here is to close the door all the way so we know exactly where the door will start from when we finally give the aperture door commands, when we give commands to open the aperture door. So what the operators have done here is completely close the door, and that procedure has been completed. All systems are going well with the Hubble Space Telescope at this time. There are no anomalies. Procedures are being accomplished step by step towards an aperture door opening of at or around 7:30 Eastern Daylight Time today. The next step in the procedures is to partially close the high gain antenna latch, and that procedure is expected to start here very soon. We're at MET 2 days, 19 hours, and 20 minutes. This is Hubble Telescope Control, Greenbelt.
Discovery, we're back with you through Mila, UHF only. Same, Steve. We lost you due to an unscheduled user that needed teeters. Okay. And you're correct, Kathy. We would prefer to have real-time data.
Roger that, Story. We assume so, and I guess, can we put the ball in your court to let us know a preferred time, or otherwise we'll just pick a convenient time? And
Okay, we'll let you know. We lose Tidris again here. We're going to be LOS from 1955 to 2025. That's another half an hour of LOS.
okay, we copy. Expected LOS 1955 to 2025.
Story, that might be just long enough to resurrect Mr. Spock. One of the symptoms of Charlie's problem was that Spock wouldn't talk to him anymore, so eventually he did a code off. We're trying to reload.
Well, that'll teach Mr. Spock what he's going to get if he doesn't behave.
Well, Charlie's been talking to him, so I think he understands. Story, since you don't have data, I'll tell you that the dump's just about complete. We're down to 5% on tank Bravo.
Could you say that again, Steve?
Yes, sir. I was just informing you, since I guess you don't have data right now, that the supply water dump's almost complete. We got Bravo down to 5%.
That's about as far as it's going to go, we think, and then you'll start coming out of tank Alpha.
Okay. Well, you want me to stop it now, then?
And Econ would like another 4 to 5 minutes, Steve. Discovery, we should be back through Tidris now.
Okay. We understand. You sound the same.
And for Lauren or Charlie, I've got an NC3 pad for them when they're ready.
Okay, Story, just a second.
There's no hurry. It's on page dash 9697 around in there.
We're ready to copy, Story.
Okay, NC3, RCS, multi-axis, roll 180, weight 204,768, TIG 02/20:08:18.0, peg 7 X plus 0.4, Y 0, Z 0, maneuver attitude NA, delta V tote 0.4, TIGO 02, Vigos we don't have, HA 334, HP 330. Under notes, no interconnect and no down mode options.
Okay, Story. It's RCS, multi-axis, TV roll 180, weight 204,768, TIG 02 slant 20:08:18.0. Peg 7s are delta VX 0.4, that's positive. Delta VY is 0, Delta VZ is 0, Delta V tote 0.4, TGO 0:02 for 334 by 330 with no interconnect and no down mode.
That's a good read back, and we sent you a command load for that. You'll find it in 202.
Okay.
Discovery, there's no hurry. The next time somebody passes by aft 14, let me know.
A14,
That's firm.
we're there.
Okay, RCS ohms heaters, left pod 2, B to auto, A to off.
Okay, we'll put B auto, A off.
And right pod 2, B auto, A off.
Same for the right pod.
Thank you.
This is Mission Control Houston at mission elapsed time 2 days, 19 hours, 43 minutes. We're just about 25 minutes away from the NC3 phase adjust burn. That'll be a short burn using the reaction control system thrusters. That burn expected to last about 2 seconds with a total change in velocity of 0.4 feet per second. Again, this burn is designed to arrest the closure rate between Discovery and the Hubble Space Telescope, which is currently at a rate of 1.7 nautical miles per orbit. Following the NC3 burn, Discovery will remain in that station-keeping distance, roughly in the neighborhood of 40 to 42 nautical miles behind the telescope, and stand by for confirmation from the stock of aperture door closing. In the event that there's difficulties encountered in closing the aperture door, the option does exist to rendezvous and provide EVA support to close that aperture door. And that is the reason for maintaining the 40 to 42 nautical mile station keeping distance today. Discovery currently in a 333 by 329 nautical mile orbit. The resulting orbital parameters following the NC3 burn will place Discovery in a 334 by 330 nautical mile orbit. Discovery now on the ascending node of orbit 43, passing out over the Atlantic Ocean.
Go ahead, Steve.
Hey, you got time for a personal question?
I got all night.
It's morning story.
Okay.
I was just wondering if you guys knew whether Eileen had had a chance to come over to Mission Control and watch any of the activities from the viewing room.
I'll find out.
I don't suppose she's there now, huh?
Not right now. I could call her over.
That's okay.
Using for Steve or Charlie.
Go ahead, story.
Yeah, Fido's asking with respect to Spock, you did do a power cycle?
Yes, we did a power cycle.
Thank you.
Yeah, story, we waited about, I'm guessing maybe 10 minutes, and tried a code escape to get back to the initialization form, and had no joy. Waited another 5 minutes, and then finally decided to do a power cycle.
Okay, thanks.
And just for information, on another program, yesterday morning, we were trying to
add a comm site, a false TDRS site to move TDRS, and we got the same problem where it locked into the program partway through and would not respond to any keyboard entries. We tried multiple code escapes and had no joy, so we power cycled it again yesterday. And both of these anomalies have been on the flight deck Spock.
Thanks, Charlie. Houston for Kathy.
Go ahead, Story.
We've got a whole hour of TDRS coverage from 2208 to 2308. Pretty close to the EMU troubleshooting on the flight plan.
Okay, 2208 to 2308.
That's firm.
Okay, Story, I copy, and that looks pretty good relative to the other activities from our end, too, so we'll attempt to put it there and be ready at the start of that coverage. Do you want to see the power-ups, by the way?
Stand by one.
My assumption, unless you say otherwise, would be that you would like to see everything from the power-ups on through, and I would only get ready up to the point of powering up the airlock power supply.
That's a great idea, Kathy. Let's do it that way.
Okay, we'll try to be ready right on 2208.
Ask Charlie if the Spock's been normal since the power up.
Yes, sir, it sure has been. We've got a good Earth map, and I've not gone back to try anything else. Maybe later on I'll try another deorbit.
Thank you, Charlie. So I don't lose you here, remember there's a 30-minute LOS, roughly 1955 to 2025.
We copy.
Houston for Lauren.
This is Mission Control Houston. We've temporarily lost our tracking and data relay satellite link with Discovery as that communications network has been handed over to the Space Telescope Operations Control Center for use in Hubble Space Telescope TDRS direct communications. We expect to be without TDRS support for about 25 more minutes. We should pass out of range of the tracking and data relay satellite east before we do acquire that capability again, so we'll first hear from the crew of Discovery again through the western satellite when we acquire there. In the meantime, we're about 10 minutes away from the expected RCS multi-axis burn, NC3, that phase adjust burn designed to arrest the closure rate between Discovery and the Hubble Space Telescope, which is currently about 1.7 nautical miles per orbit. It's about a 2-second burn that will result in a total change of velocity of 0.4 feet per second, placing Discovery in a 334 by 330 nautical mile orbit. Again, that phase adjust burn sets up station keeping at about 42 nautical miles directly behind the Hubble Space Telescope on the velocity vector, and will remain there until we have some confirmation or status from the stock on the aperture door closing operation, which is scheduled for later this morning. In the event that some problems were encountered in the closing of the aperture door, the option is retained by this station keeping strategy to rendezvous with the Hubble Space Telescope and support the aperture door opening with an EVA. but as of yet, there's no reason to expect that there will be any difficulties with the aperture door opening. And hopefully once that's accomplished, the stock will release the flight control team and the Space Shuttle Discovery and crew from continued Space Telescope support. Discovery now beginning the descending node of orbit 43, tracking out high over the northwestern portion of the African continent. Discovery currently in a payload bay to Earth attitude. Immediately following the NC3 phase adjust burn, Commander Lauren Shriver will be maneuvering Discovery to the gravity gradient attitude, which is a nose to payload, or nose towards the Earth attitude. That attitude is being opted for at the special request of the IMAX customers who feel like their view of the Earth from the payload bay IMAX camera position is greatly enhanced over other attitude options in this GG attitude. So in order to facilitate some spectacular IMAX photography of the Earth below today, we'll remain in that gravity gradient attitude for some time. All quiet here in the flight control room. All systems aboard Discovery continuing to work very well. No systems issues being pursued here by the flight control team. At 2 days, 20 hours, and 1 minute mission elapsed time, this is Mission Control.
This is Hubble Telescope Control, Greenbelt. We're at MET 2 days, 20 minutes. Correction, 2 days, 20 hours, and 4 minutes. Operators here at the Space Telescope Operations Control Center are in the process of wrapping up sequence number 62. Sequence 62 is titled Deployment Latch Release, and that's simply an effort to partially close the forward and aft solar array latches to relax the pressure on micro switches there on the latches. Right now, the status of the telescope is very good. All systems are nominal. They're working well on the Space Telescope. There's no reason to believe that we won't have a good aperture door at the scheduled time, which is on or around 7:30 this morning, Eastern Daylight Time. In the last couple of sequences here, we've received verification that the door to the telescope, the aperture door, which was open slightly by about 1.7 degrees, we went through a small procedure to close that door, and that procedure was completed without any problems. The door closed right as expected. The idea is to have the door in a known position before you open it, so that you know exactly how far it travels when you do open it. That door is nominally to open to 105 degrees, and the idea here is to make sure that it starts at the 0 degree mark, completely closed, before you start it. So that procedure has been completed, and we're standing by. This is Hubble Telescope Control in Greenbelt at MET 2 days, 20 hours, and 7 minutes.
Discovery, back with you. Eaters West.
Loud and clear, Story.
The same. And could you give us a burn report?
Story, I wish you guys had been here to see it because you'll never believe it. The burn went, well, superb is an understatement. Residuals were 0.01, 0.02, and 0.01.
I'd believe
Dr.
it.
Shriver gets better with age.
Well, I have to go along with that. And we know the TIG was on time.
That's affirmative.
If you got a minute, Charlie, I'll ask you some questions about the Spock.
Okay, I'm ready.
Was the MET clock still running?
Yes, sir. Everything, the MET clock was still running, so it had not gone to halt.
And did the screen lock up? I think you said it did.
Say again?
Did the screen lock up? I think you said it did.
That's affirmative. We could not access anything. What was left at the time was the opportunity page with about 5 Edwards opportunities. The one that I selected, I had selected Edwards Rev 60, and it gave us the question mark. And after a couple of minutes, we got the message that I gave you.
Okay. I guess the error did occur during the deorbit target calculations then.
That's affirmative. And we had completed the calculation on Edwards course Rev 46 with no problem.
And were there any keystrokes at the time it failed?
No, sir. In fact, I had asked for, I did it in 2 separate evolutions. As a matter of fact, I asked for the next 12 hours and got the Edwards 46, and then came back into the deorbit program and asked for the next 30 hours and just selected the Edwards 60 opportunity, and that was when we had the problem.
Okay.
And I would like to report 10-2 cabin maintenance complete.
Thanks, Charlie.
Okay.
They're saying if it ever fails in the future, that a picture of the screen may help. And as you well know, if all else fails, the power cycle does help.
Okay, thanks very much, Story.
Houston, for Lauren.
Go ahead, Story.
DAP A4 may get your rates down a little lower going into GG.
Well, we thought we had the for standby. We'll check. And Story, you're right. We did have the wrong DAP set in. That's a characteristic of the DAP book, apparently.
Okay.
And Houston Discovery.
Go ahead, Lauren.
Just wondered if it was time critical to set up the red hot temp and high and get the flash evap back on, or if you want that done on time.
We'll get back with you on that, Lauren.
And also, the 3 steps is listed there. Is that the way it's supposed to work? Flash evap A is currently on. Do we need to turn it off first?
Lauren, we'd like you to do that on time, and all you need to do is rad controller out temp high. Ignore the next 2 steps.
Okay.
teeters will be looking over the tail here, so we may be dropping in and out after 2101. If we don't have your teeters east, we'd appreciate an item 14 on SM antenna. That'll get us over to east.
Roger that. Was that 2101?
That's a firm lower.
Okay, if we don't have your teeters by 2101, we'll do an item 14.
Thank you.
This is Mission Control Houston. The two boxes at the lower left and right quadrants of this field of view depict
In Discovery,
the star view.
Required on your spec 66 water. We're looking at it.
Okay, Story. What we're doing is resetting the limits from the dump. We did not reset back to normal after the dump was complete, and Charlie's doing that now.
Okay.
This is Mission Control. The two boxes in the lower left and right quadrants of the frame here depict the views through the star trackers along the -y and -z axis that are used for aligning the inertial measurement units on board Discovery. Regular IMU alignments are done in order to refine the orbiter's onboard navigational platform. And the star trackers are star sighting systems that allow the vehicle to identify predetermined stars, decipher their location and the vehicle's position in reference to their location, and feed that information to the inertial measurement units. The digital animated depiction of the orbiter in the upper half of the frame shows that the vehicle is now in the gravity gradient attitude with a nose towards the Earth, and the payload bay pointed towards the north. Again, this GG attitude requested for special photographic purposes by our IMAX folks, who found yesterday during the gravity gradient demonstration test that this attitude provides an exceptional view out the overhead windows of the vehicle of the Earth's horizon and the Earth below. The yellow numbered dot that's tracking through the lower left-hand quadrant of the frame through star tracker Y is actually a star that is passing through the line of sight of that star tracker. Discovery currently tracking out over the South Pacific Ocean, just about to cross the equator on the ascending node, and the beginning of orbit 44. All quiet here in the flight control room. All systems aboard Discovery continuing to work very well. No systems issues being pursued here by the flight control team in Houston. And we're continuing with stepping through a nominal flight day 4 timeline. Currently station keeping behind the Hubble Space Telescope, standing by for some status on the efforts by the stock to open the aperture door on the Hubble Space Telescope, again in the event that any difficulties were encountered, and shuttle crew member assistance would be requested. Discovery is in a position to rendezvous with the telescope and provide EVA support to do that.
to acknowledge we've maintained good comm. Be handing over here to Tigris East.
Roger.
This is Mission Control Houston. Our next television event expected to be some unscheduled downlink television from the Space Shuttle Discovery, just now crossing the equator and beginning the ascending node of orbit 44. In just a few minutes, Discovery will be tracking over Mexico and into the Gulf of Mexico. Just about the time it gets into the Gulf vicinity, it'll be tracking from the dark part of this orbit into daylight. At that time, we expect to take some live television from the payload bay cameras via the KU band system. Just after tracking out of darkness into light, and about the time we begin to acquire this unscheduled live downlink television from Discovery, orbiter should be crossing over the Florida Peninsula, providing a viewing opportunity for residents in the Orlando Kennedy Space Center vicinity at about 5:52 a.m. Eastern Time. Tracking fairly high with a maximum elevation of 72 degrees above the horizon, Discovery should be visible tracking from the west-southwest to the southeast.
This is Hubble Telescope Control from Greenbelt, Maryland. We're at MET, 2 days, 21 minutes and, 2 days, 21 hours and 7 minutes. We are in a normal mode with the Hubble Space Telescope with no anomalies to report. All systems are go. We're approaching checkouts for the aperture door opening. Sequences to open the aperture door will begin with a establishment of the forward link communications at approximately 7:30 Eastern Daylight Time this morning. There, of course, will be no television downlink of the aperture door opening since the televisions and the KU bands are on the orbiter, which will be about 40 to 42 miles away from the Hubble at time of aperture door open. Right now, everything's going well on the telescope, and we're waiting to come out of this LOS before we continue to send commands up to the telescope in routine checkouts that are scheduled for this morning.
Discovery, we're uplinking more copies of the flight plan to you.
Okay, thank you.
This is Mission Control Houston. We're taking live television from the payload bay cameras aboard Discovery. This perspective through the aft crew cabin windows. This view taken from the wide angle camera mounted on the elbow of the robot arm. Discovery still orbiting in darkness due to cross the terminator into daylight in just about 10 minutes. In the meantime, the only source of illumination in the vicinity is the cabin's lights. This is Mission Control Houston, with Discovery oriented with its nose towards the Earth. This view from the elbow camera on the robot arm of Discovery depicting some fairly extensive electrical activity in the atmosphere below. The two fixed larger lights in the lower left-hand quadrant of the frame are the aft cabin windows of Discovery, illuminated by the cabin lights inside. Discovery just about to cross the coast of Mexico, and quite visible just off the coast in the Pacific Ocean, a substantial amount of electrical activity and thunderstorms below. This is Mission Control Houston as the sun begins to illuminate the Earth as Discovery makes her way around the planet at 331 nautical miles. It becomes apparent that the activity below is much farther out than directly below the vehicle, but in fact as far out as the Gulf of Mexico. Discovery just beginning to cross the Pacific coast of Mexico. This camera view looking ahead of the orbiter vehicle's path at the severe weather that affected central Texas and the south Texas coast yesterday.
Go ahead, Story.
We're getting TV down here. Is that lightning that you see down there?
That is extreme lightning. That's correct.
Boy, you bet. CCTVs. I've never seen them pick it up like that.
Okay. I don't know if you're looking through camera B, but if you are, you're looking in the direction where Steve's trying to film HST in the sunrise and the lightning.
Okay, we're getting the elbow camera, but we're sure getting the lightning and the sunrise.
Okay, if you come to the, kind of up to the horizon and then to the right to the elbow camera, you may find HST. Let me see if I can give you a GCA here. G-Story, it almost looks like it's from the orbital orientation. If you go to the horizon and come up maybe 20 degrees with it being straight across the bay, you're probably going to be pretty close.
Thank you, Charlie.
Okay.
This is Mission Control Houston as the Space Shuttle Discovery passes high out over the Gulf of Mexico. Residents in the Houston and the Orlando Kennedy Space Center vicinity ought to have a viewing opportunity. Those residents in Houston could look some 41 degrees above the horizon as Discovery passes from the south-southeast to the southeast.
Well, if you guys remind us the next time, if you don't already have the cameras, we'll try to use the RMS elbow camera and pick up HST for you.
Thanks, Charlie.
And potential viewers in the Orlando Kennedy Space Center area could look to see Discovery track from west-southwest to southeast with a maximum elevation of about 73 degrees above the horizon. Discovery throwing off sunlight as it has just passed from darkness to light, crossing the terminator over the Gulf of Mexico. Charlie Bolden, pilot aboard Discovery, mentioning that as we were observing an orbital sunrise with some spectacular lightning in the Gulf below, Mission Specialist Steve Hawley was busy capturing the same phenomena with the IMAX camera with the addition of the Hubble Space Telescope in sight. Discovery now stationed keeping some 42 nautical miles behind the Hubble Space Telescope, holding that position in the event that they would be requested to rendezvous with the telescope and assist in the opening of the telescope aperture door. All systems aboard Discovery continuing to work very clean. No issues being worked here in the flight control team. At 2 days, 21 hours, and 20 minutes, this is Mission Control.
Discovery Houston, you're going to have an LOS here from 2135 to 2201.
Story. We'll look for you at 2201.
And we are going to have a Dakar UHF, so we may have UHF only over the west coast of Africa. And could you cycle flash of app controller primary A off and back on, please?
You'd like A off and back on?
That's firm.
Roger.
In Discovery will be UHF only here through Dakar for about 10 minutes.
Okay, we hear you through Dakar.
The same.
Story, do you expect that you'll have TV capability next sunrise?
We don't think we will have TV at the next sunrise, Steve.
Okay. If you do, sometime today, have a sunrise coming up where you have TV coverage, I'll try to set up one of the cameras to look at the limb and the HST and all that if you like.
We'd love it.
And Houston Discovery.
Go ahead, Kathy.
Yeah, Story, we're just about finished with the rest of all the morning's middeck activities and going to start breaking into the airlock here shortly. One other thing that occurred to me to ask is, do you need us to change TIFLs for the EVA data downlink?
We will need to switch in TIFLs, and we'll probably do that for you.
Okay, we'll leave it in your hands.
The one we got right now will do, Kathy.
Understand, current TIFL's good.
And after a while here, you may get the G23 RCS systems like we did yesterday. No action required.
We copy, Houston.
This is Mission Control Houston. That last exchange between Capcom Story Musgrave and Mission Specialist Kathy Sullivan aboard Discovery. Sullivan reported that most of the middeck activities scheduled for this morning are wrapped up and they're ready to move into the airlock and start preparing the EMU number 2. That's the spacesuit that Sullivan donned in preparation for possible EVA activities in conjunction with the telescope deploy. Those proved to be unnecessary, but in the process of preparing, Sullivan reported that she'd received 3 power restart messages on her display and control module. Those messages are suspected to be erroneous since no power restarts were attempted. Anyway, the troubleshooting procedure that they're about to get underway with is to diagnose that anomaly and see if there's some way to define the problem. The interest, of course, in assuring that that spacesuit is still in good shape and available to support an EVA is in the event that the aperture door opening on the Hubble Space Telescope later this morning runs into some problems that could use a little assistance from shuttle crew members. Discovery can rendezvous and provide EVA support.
Houston Discovery, did you call?
Got just a couple changes to your EMU2 troubleshooting procedure. If you don't have it in hand, it'll be easier just to copy them than to go get it.
Okay, stand by just one. Let me get pencil and paper in hand, Story. Okay, Story, ready to copy.
Step 15, delete power SCU. And also in 16, delete power to SCU.
Okay, Story, the is pretty weak and a little garbled. Let me tell you what I think I copied. In step 15, delete power to SCU, and in step 16, delete the same. And I'd have to go look at the procedure you sent up and make sure that was correct.
Okay, in step 23, instead of purge valve off, it's purge valve open.
Okay, at step 23, purge valve should go to open OPEN vice OFF. And can you verify I copied the step 15 and 16 correctly?
You sure did, and that's it.
Okay, and those are the only changes?
That's it, Kathy.
Thank you, sir.
Discovery, we're 2 minutes to Dakar LOS. Pick you up again at Tidris at 2201.
2201, okay.
Discovery Houston, we're back with you for about 2 minutes.
Got you loud and clear, Story.
And the same. We'll be going through the standard Tidris LOS here. Pick you up at about 2208.
Okay, 2208.
And we have TV capability from 2215 to 2230. We'll take anything you want to send us.
Okay, understand TV from 2215 to about 2230, and we'll look around and see what we got.
And in the Bay IMAX, would appreciate anything over the next pass, eastern United States.
Charlie's nodding. He says he understands.
Okay.
And Houston Discovery will be ready in the airlock at your 2208 AOS.
Thanks, Kathy. We'll be ready.
This is Mission Control Houston. We've passed out of range of the tracking and data relay satellite system. We'll acquire again through the Western satellite in just less than a minute. Just about 7 minutes from now, we expect to take some live downlink television from Discovery. Subject unknown. If the crew has not got some cabin TV to show us or some video to dump from their tape recorders, then we'll have the opportunity to continue to look outside the orbiter. But we'll be standing by to see what the crew has for us. Again, that upcoming at about 5:49 a.m. Central Time, just about 8 minutes from now.
This is Hubble Telescope Control in Greenbelt. All systems are nominal on the Space Telescope at this time. Operators at the stock are standing by. The next sequence of events that are scheduled to take place involve the opening of the aperture door on the Space Telescope. At this time, the telescope's going through
Discovery. We're up on Tidris West.
We got the story.
At this time, the telescope's going through some pre-programmed slews, and the last slew before aperture door opening was scheduled to take place roughly 4 minutes ago. Waiting for verification that that took place.
Houston Discovery.
Go ahead, Kathy.
Okay, Story, I'm in the airlock, and if you'll give me just about 30 more seconds, I'm getting ahead of the game by putting the gloves on the EMUs. And would you like us to go to the EDA comm config on 5-6 at this time?
That's firm, Kathy. After power up, you can go to 5-6.
Okay, we're in work. Okay, Houston, we're going to step 3 on EMU power up at this time.
We're ready, Kathy.
And power switches, correction, mode switches are going to power on my mark, EMU 1, mark, EMU 2, mark, bus selects to main A, EMU 1, mark, EMU 2, mark, and Story, do you have the data, or do you need a readout of what I'm seeing on 18 Delta?
Stand by 1. Could you report the data to us, please, Kathy?
Sure thing, Story. EMU 1, I'm showing input volts what look like about 18.5 and stable. And EMU 1, the amps input is showing about 0.9 amps and stable.
Okay.
EMU 2 is identical on volts as close as my eye can tell it, and about 0.1 on input amps.
Okay.
And Story, help me out here. I don't want to overwork the air to ground if you guys are following through here, but I want to make sure you get any marks on switch throws or data that you want. So I'll give you a mark on every major suit.
This is Hubble Telescope Control in Greenbelt, Maryland. We're within 30 minutes of the begin of sequence 65. Given good telemetry and good communications acquisition from the TDRS satellite in half an hour at 7:25 Eastern Daylight Time, operators here at the Space Telescope Operations Control Center will begin commanding for sequence 65 of the aperture door opening. That sequence is expected to last until about 7:49, when we'll be able to hopefully give the thumbs up sign to the Mission Control Center in Houston that a rendezvous or a re-rendezvous with the telescope won't be necessary, because we'll have a good aperture door open. Again, sequence 65 will begin at 7:25 Eastern Daylight Time.
Discovery, we're back with you. We had an unexpected dropout.
Okay, Story, we copy. And for the EVA guys, we're ready for power up step 6 in the airlock, and I held off till I had you back. Figured you'd want to see that.
Thank you very much. And we're following you, so you do not need to mark each step. We're with you.
Roger that. Here goes step 6.
In Discovery, for the next 8 minutes, we can receive any TV you send to us.
Okay, Story, it'll be camcorder.
Great.
And when you're set up, let us know and we'll send it down.
We're ready, Steve.
Okay, Story, this is looking out window W1 at HST rising. I apologize for the reflection, but the bright object there is the Space Telescope on our previous sunrise path.
Charlie, we have Hubble down here.
The time when it was the time before your pass where you were looking at the lightning and the sunrise.
We have HST down here, Charlie.
Okay, and as we go along, I'll be zooming in and out, and I'll also try to pan along, or I tried to go down and look at some lightning. You'll see that in a few minutes, or a few seconds, hopefully. And then I'll give you a shot of, at least out of the window, from the edge of the window to the other edge with the horizon, with the sun coming up. And this will end with sunrise when HST disappeared. The disk was up in the frame. So I'll just let you look and won't say anything else.
Thank you, Charlie. And Discovery, we'll be working on opening up the Hubble aperture door, starting with commands maybe around 2252. If all that works well, Charlie, you also may have an opportunity to do the in-cabin IMAX on the East Coast.
Okay, Story, we understand, and we're looking forward to some good news.
And you can use the 40-millimeter lens there.
Okay, so you're going to tell me whether you want ICBC or IMAX, because we were prepping for ICBC.
And we want the Icky-Bicky on the East Coast anyway, whether or not the aperture door is confirmed open.
Okay, we copy, and we'll go down and re-rig Max for exterior and the 40-millimeter lens.
Thank you, but don't use it until we give you a confirmation on the door.
Okay, and we'll wait until the last minute because we've got it set up to do the EMU checkout parallel to this checkout that you guys are doing.
Okay, great.
There's your lightning every once in a while Story.
And Houston, in the airlock, we're going to step 7 on primary regulator fan pump check.
Okay, Kathy. EVA's with you. Kathy, we're receiving engineering data on both suits.
Okay, Story, I copy that.
Story, I just figured out the blinking light there is a reflection from the record light on the VTR. On the camcorder, I'm sorry.
Yeah, thanks very much.
Enjoyed that.
We thought you were having some visitors.
That's HST in the upper right of the frame, kind of going and coming as we move around on the horizon.
That limb glow you get at 300 miles is sure different than 150.
What I remember from my other flight is that what you just saw, the Earth's limb there out of one window, sometimes you had to go up to the forward part of the cockpit and look through all 6 windows to see. That's the part of being up here that's significant at 3:30.
It's a beautifully composed picture, Charlie. The limb in HST.
And Story, I'm just completing exit procedure. Do you need that data read down, or are you getting enough now?
We're getting data. We see the fans on.
I'm sorry, Story, could you say again? I was in the airlock and didn't hear the speaker.
We've got good data. We see the fans on.
Okay, and are we go for step 10 of the tags message?
Your go, Kathy. And for Charlie, we've lost KU band, so we're not getting any more TV.
Okay, we copy that story. And Story, are you still there? Voice?
Yeah, we've got S-band.
Okay, we're going to take hydraulic circ pump number 1 to on, and I'll give you a mark.
Okay.
If you'll let me know when you're ready.
Max says we're ready, Charlie.
Okay, on 3, 2, 1, mark. And Houston Discovery.
Go ahead.
Yes, Story, that transient on CRT-1 was me, a switch era. Went to standby.
Thank you.
And Houston Discovery for EVA.
Go ahead, Kathy.
Okay, watching the input amps on EMU2, when step 11 was accomplished, first of all, there was no power restart, as you probably saw also. Secondly, I was showing input amps at step 9 of 4.5 plus or minus probably less than a tenth of dither, and it's my perception that the amplitude of that dither did increase when the circ pump came on. But it's a tough call. If you guys have got the strip charts running, you can tell me if I'm right or if I'm convincing myself of something that's not there. But at any rate, I show myself at step 13 and proceeding.
You got to go to continue, Kathy.
Okay, going to step 13.
And for Kathy and Discovery, we're about to go off the tail on teeters here. We may drop out.
Okay, Story, we copy. And do you want me to proceed or wait until you regain comm?
Unfortunately, we'd like you to hold right there until we get good comm.
Okay, you got me just before selecting main B. I'll hold there.
Thank you. And Charlie, you can take circ pump 1 back to GPC.
Okay, circ pump 1's going back to GPC, mark. That Story, as you can probably tell, we went ahead and did the LIO changeout a little while ago when we got the message, and we also looked for water and did not find any this morning.
Thank you, Steve. And Kathy, we'd like you to finish step 13 and then wait there.
I copy, Story. Finish 13 and hold there. Does that include the manipulations of moving the suit in and out of the airlock?
Kathy, take the power to SCU and hold there. Thank you.
Okay, Story, that's what I thought you meant, and that's complete. I was about to come ask you for that anyway.
Kathy, up to this point, all the strip chart data is normal.
Okay, Story, copy that, and standing by till you advise me you've got data again.
Okay.
And Story, a quick ICBC question.
Go ahead, Charlie.
The time that was listed, the MET, is that their TCA that they want us to start and shoot the 30 seconds from?
Houston for Charlie. at the time you got there's acquisition of the desired target. It's probably not optimum. That's the westernmost point at about a 5-degree elevation angle.
Okay, we think we understand, and as what our plan is then is to make sure that as best we can guess, we'll at least get the east coast, the coast itself, in the frame.
And that is your judgment too. You look and see if you think it's a good picture. That's totally your judgment.
Okay, thank you.
Kathy, we got good data now. You can do those manipulations and then hold there for our call.
Okay, Story, I'll go over to Main B and back to SCU, and we may have to step around. We got people double booked here for things to do, but we'll get with you on moving the suit around as soon as we can. Here comes airlock supply, Main B. And Story, EMU-2 is now powered off of Main B. It's back on SCU.
Thank you.
And subjectively, the input amp oscillations look very similar to what I saw in Main A.
And you are doing the manipulations here, Kathy?
This is Mission Control Houston, as Mission Specialist Kathy Sullivan continues with the EMU-2 troubleshooting.
Coming down from the flight deck now, and we're going to let him try to duplicate exactly how he moved EMU-2 on flight day 2.
That'd be great.
While Kathy Sullivan continues with EMU-2 troubleshooting procedures to help solve a mystery around the power restart messages she received on her suit the day before yesterday, the telescope operators at the Space Telescope Operations Control Center are getting prepared to send their commands.
Charlie's in the process of taking EMU-2 out of the AAP, and on flight day 2, the left side fitting on the AAP was very reluctant. Really took some pushing and bumping by Charlie to get that loose, and he's doing the same today.
Thanks.
And as is expected in cases like that, I heard some of that couple through into my comm as bursts of static.
Again, while EMU troubleshooting continues, the stock is preparing to send commands to attempt to open the aperture door on the Hubble Space Telescope, and as such, we will transfer the origination point of NASA Select Television to the Goddard Space Flight Center at the Telescope Operations Control Center. That handover coming momentarily.
Okay, Story, we're starting to work our way out of the airlock. And Kathy got her first power restart right about here, as I got her right to the airlock hatch, the head of her.
Okay, Charlie.
And NASA Select Television now emanating from Goddard Space Flight Center's Space Telescope Operations Control Center. Operators are waiting for some indication of communications link up to TDRS. And in the front of the field of view on NASA Select is current director for shift number 1 of
Turned heads upside down and in the foot restraints.
Thanks, Charlie.
and in the NASA Select television picture.
Step 17.
stand by.
And Larry Williams there, who's the operations controller. He's responsible for conducting the day-to-day operations with spacecraft here at the Space Telescope Control Center. At this point, we have no indications of communication link with TDRS. Procedures are being sent back up through TDRS, the high-gain antenna and the Space Telescope to acquire communication. And another view on NASA Select of Space Telescope controllers. This is the mission operations room at the Goddard Space Flight Center STOC, or Space Telescope Operations Control Center.
Okay. And story ready for, is it step 17?
We're ready, Charlie.
Houston Discovery.
And in the field of view, center of field of view on NASA Select television,
And Charlie is now
Shift Supervisor
again.
Pete Patero and
Hey, thank you, Ed. And no need for Charlie to acknowledge, but we've not had communication telemetry from the HST, so he does not have to worry about the in-cabin IMAX.
Sorry, Story, we didn't copy that clearly. Could you say again, please?
We've not had telemetry from Hubble, so we have not run the aperture door tests. So Charlie does not need to think about running the in-cabin IMAX, only the in-bay IMAX, if, in his judgment, it's a good scene.
Okay, we copy you that time. Thank you.
And for Lauren, if you plan to run the in-bay IMAX, we need to get the FES off.
This is Mission Control Houston.
Fest coming up.
Thank you.
This is Mission Control Houston. The degradation in air-to-ground communications that we're experiencing right now is due to the EMU troubleshooting in progress. EVA communications have been configured in support of this test, and a lot of the sounds that we're hearing are noises from inside suits like fans and RF interference in the cabin. Mission Specialist Kathy Sullivan approaching the end of the troubleshooting procedures, and which will include powering the suits down and deconfiguring the EVA communications. So we expect this degradation in air-ground comm to continue for at least a little while longer while they continue the troubleshooting procedures. This is Mission Control.
And again, images emanating out of the mission operations room at the Goddard Space Flight Center. To the back of the field of view is operations controller Larry Williams and shift supervisor Pete Patero, who are working with the operators here at the stock to reestablish communications with the TDRS satellite.
Okay, Story, we've made a full out into the middeck and back into the airlock on battery in step 17. The only thing we have not done, again, is in and out of the AAP, and we've had no power restarts.
Okay, Kathy, we're ready for 18.
Roger, 18. And Story, I'm going to be just a minute on 18. I'm going to take the EMU back out of the airlock and get it back in the AAP.
Okay, that'll be fine. That's your call.
And Story for IMAX.
Okay, Charlie.
We're going to wave this picture off because we're all in agreement. It's really, really hazy. We had a gorgeous pass yesterday, and we feel certain we can get you something better than what you got right now. Lots of clouds and just too much haze.
Thanks. We appreciate your judgment.
Okay.
And Houston for EVA. Fan coming off step 18 now.
Okay.
Houston Discovery, SCUs are swapped, and we're about to power up EMU2 on SCU1.
Thank you, Kathy.
Houston Discovery.
Go ahead, Lauren.
Yeah, we've just been watching the right RCS tank temperature for fuel. You probably noticed it's tripped the alarm.
That's affirmed and no action required. Those are due to the set points on heater B.
Say again your last story.
Those messages are due to set points when you're using B heaters.
Okay.
No action required.
Okay, we copy that. Thank you.
Houston Discovery, we're complete in step 18 to the point that it says to contact you. And one procedural error that I guess you guys missed it and we missed it too. The fan off step applies to both EMUs, not just we've misconfigured.
This is Hubble Telescope Control in Greenbelt. The attempt to begin procedure 65 or sequence 65 on the aperture door open did not begin. There was no acquisition of signal with the telescope on a high gain antenna. So operators here at the stock are reconfiguring to another attempt in about 7 minutes on the low gain antenna.
And Houston Discovery.
Discovery, we're about to go on a 40-minute LOS here. We'll pick you up at 23:51, and Kathy, just continue on the procedure and go ahead and finish it up.
This is Mission Control Houston. EVA controllers here in Houston happy with the data they saw during the EMU checkout, and have given Kathy Sullivan a go to continue with the procedures to power down the spacesuits. They're going to continue to look at the data acquired over the last orbit, but at this point the condition that was recognized 2 days ago was not reproduced, and controllers here feel like that EMU2 is a healthy spacesuit and available for EVA support. This is Mission Control.
And we have NASA Select back at the Space Telescope Operations Control Center in Greenbelt, Maryland. Pointing control systems engineer looking over data. pointing control systems engineer is responsible for the health and safety of the pointing control system, including the gyros and the reaction wheel and the safing system. Operators of the stock are awaiting some indication of acquisition of signal with the telescope through the TDRS satellite. That acquisition now expected at about 7:55 Eastern Daylight Time. Engineers are attempting to acquire through the aft low-gain antenna on the telescope.
Discovery Houston through Dakar, UHF only.
And a view on NASA Select of the optical telescope assembly engineer.
UHF only through Dakar.
View there of the operations manager's console. The operations manager has the broad contractor management responsibilities for the cost control and the development and the schedule control capability for the HST operations. And that includes systems procedures and the operations personnel. This is the director who manages the contractors and coordinates the efforts of the various teams and initiates and leads the special studies and negotiates interfaces and performs other required functions to ultimately manage the operations team here at the mission operations room. Operators are looking at telemetry, hoping for a good lock on data, waiting for a verification of a lock on the TDRS satellite and the low-gain antenna on the HST. And stock receiving telemetry now that there is a lock on the low-gain antenna, and they're beginning to receive commanding telemetry. Telemetry reads in bounds, and they're going to begin the commanding up for aperture door here as soon as they have a strong fix on the telescope.
Discovery Houston on UHF. We're about to go LOS Dakar. We're going to pick you up on the West TDRS around 2351.
Television emanating from the Space Telescope Operations Control Center here in Greenbelt, Maryland at Goddard Space Flight Center. In the field of view is most of the mission operations room, including the electrical power systems team on the forward part of the image, and in the center of the field of view is the shift supervisor and the operations controller, and behind them to the center of the field of view is the science teams and the data handling engineer for the science team. To the right and out of the field of view are the rest of the team members, including the optical telescope assembly engineer, and the pointing control systems engineer. To the upper part of the screen is the optical telescope assembly engineer and his team. It's the optical telescope engineer who is responsible to ensure that the optical telescope assembly is within operational thermal limits, and he uses the online thermal monitoring program. He also monitors the status of the fine guidance sensors. And a shot on NASA Select of the pointing control systems engineers. These engineers are responsible for the health and safety of the pointing control system, and that includes the gyros, the reaction wheels, and the entire safing system. They also monitor the target acquisitions and verify that the HST attitude is held stable. This is Hubble Telescope Control, Greenbelt, Maryland at MET, 2 days, 23 hours and 36 minutes. There's a group of operators here at the stock that are looking into into several possibilities, one of which is that the telescope has gone into sunpoint safe mode. Now, sunpoint safe mode is a it's a software safe mode where the telescope, after a time, if it's not given the proper commands or if it loses communications for a period of time, automatically safes itself. It does this by pointing the aft end towards the sun so that it keeps some minimum thermal boundary and continues to recharge its batteries with the solar rays pointed towards the sun. That also protects, if we were in observations, the aperture of the telescope from any bright objects like the sun. This is Hubble Telescope Control, Greenbelt. We're at MET 2 days, 23 hours and 46 minutes. Operators here at the Space Telescope Operations Control Center are working on procedures to recover out of a mode of operation called safe mode, and that's safe mode is a state that the telescope goes into when it either does not receive the communications that it's been told to receive, or if for some reason when the aperture door is open, the aperture door drifts towards a bright object, or some sensor tells the telescope that there's some danger to the optics on the telescope. Obviously, with the door open, with the door not open, the latter two examples did not cause any safe mode, and operators here believe that it's probably lack of the communication to the satellite. There's been some dropout on the TDRS satellite over the last half a shift, and either dropouts or late acquire of TDRS communications periodically during the mission, and it's very possible that several of the commands for the slew activities that were to take place over the last few hours did not take place, and that would have been caused by the high gain antenna being in the wrong position. So operators now are marching on to getting out of the safe mode. This is safe mode is protection for the telescope, and it's not an unusual mode to go into. It is one of several types of this is called sunpoint safe mode, but there are several types of safe modes that the telescope could go into and probably will go into in the future. This just happens to be the first time that the telescope has done this. They'll work the procedures that are already in place to get out of safe mode and reacquire the telemetry through the high gain antenna and proceed on with opening the aperture door.
Discovery, we're back with you. TDRS West.
Loud and clear, Houston. And for information on EVA, we held at the end of step 17, which was contact MCC, no power restart to serve, for quite some time. And just about 2 minutes ago, I went through steps, I believe it's down to 24. The suits are both back in the AAPs. They're powered down. Fans are off, O2 actuators off per the procedure. We've not gone into any of the post-EVA activities. We're just waiting there to hear from you.
Thanks very much, EV2. And you can go ahead and continue and wrap that up.
Okay, understand. We can continue to back out of the EVA preps per the steps remaining on the tags message, and we'll put that in work shortly.
Thank you.
And Story, during the loss period here, have you by any chance gotten any HST updates?
We'll get a summary to you very shortly. They've not tested the aperture door yet.
Okay, we copy.
And Story, the way the comms been going, I'm almost afraid to ask the next question. But can you anticipate the next time that you'll have downlink TV capability?
We'll get that to you.
It's no rush. I'm just, we're all just thinking about things that we may be able to show you if you were to come and ask us.
The next time, we'll get you some good times, but the next time will be when we get Teeters East.
Okay.
About 3 days and 30 minutes, roughly 35 minutes from now.
Okay.
This is Hubble Telescope Control, Greenbelt. Indications from operators here at the stock is that the safe mode that the telescope has gone into is the inertial hold mode, which is the easiest to recover from. The inertial hold mode permits maintaining the existing attitude of the telescope, and it merely suspends the science operations, or would suspend the science operations if and when we go into the IHM again. Indications are that the telescope went into the hold safe mode due to a high gain antenna over gimbling, and we don't have any more information on that at this point. Operators are looking through their telemetry to gather more of the data.
Houston Discovery.
Go ahead, Kathy.
Okay, Story, we're complete through step 26 on message 28 Bravo.
This is Mission Control Houston at mission elapsed time 3 days and 8 minutes. Mission Specialist Kathy Sullivan on board Discovery in the middeck and airlock has completed the troubleshooting procedures with her spacesuit, EMU number 2, the suit that she wore day before yesterday, and preparations for contingency EVA possibilities. Towards the end of that EVA, Sullivan reported that she'd received 3 power restart messages on her display and control module display. And those were thought to be erroneous messages since no power restarts were attempted. In order to confirm that hypothesis and determine whether there are any other problems, a long series of procedures were developed and sent to the crew this morning. Kathy has worked through all the steps in the troubleshooting procedures without recreating the condition that occurred late in the EVA preparations on flight day 2. At this point, flight controllers here in Houston analyzing the data that was received from the suits over the last orbit, but based on the preliminary look at the real-time data, there are no reasons at this point to consider that EVA any less than fully capable of supporting EVA. All systems aboard Discovery continuing to work very well. Things very quiet here in the flight control room, as there are no issues or orbiter system problems being pursued. Flight controllers here in Houston very interested in the activities at the Telescope Operations Control Center and anxious to hear of the status of the aperture door opening process. Discovery now on the ascending node of their orbit, just about to cross the equator and begin orbit 46. And Discovery in a 334 by 330 nautical mile orbit, trailing behind the Hubble Space Telescope roughly in the range of 40 to 42 nautical miles, holding that position in order to preserve the option for a rendezvous and EVA to assist in opening that aperture door. Should telescope operators fail to open the door by remote commanding today, there is the opportunity to perform a Flight Day 5 rendezvous with some burns scheduled for later this afternoon to set that up. But in the meantime, flight controllers here in Houston and the crew and Discovery standing by to learn the status of the telescope operators' efforts in Greenbelt, Maryland at 3 days, 11 minutes. This is Mission Control.
Discovery, Houston, with some Hubble information.
Go ahead, please.
They've delayed the door verification test. During slew maneuvers, telemetry was lost, so they initiated a safe mode recovery, MET, 2 days, 23 hours, and about 5 minutes. They did recover telemetry about 22 minutes later. HST was in inertial safe mode. The problem apparently was a difference between the high gain gimbal torque commands and the high gain gimbal resolver signals. But they do have telemetry back, and they're back progressing on.
Okay, we copy, and thank you for the update.
And while we've got you, the last half an hour of TDRS East will be again an LOS this time. That's from roughly 3 days, 1 hour and 1 minute, to 3 days, 1 hour and 33 minutes. That's the last half an hour on TDRS East.
Okay, we copy.
And for the in-bay IMAX, if Madagascar's looking good as per your flight plan there on orbit 46, that's around 1 hour and 17 minutes. If that looks good to you, it's always your discretion. It is a good target of opportunity.
Okay, yeah, I think we were planning to do that, Story.
Okay, thanks.
This is Hubble Telescope Control, Greenbelt, Maryland, at MET. 3 days, no hours and 17 minutes. A little bit about the software inertial hold mode.
Yeah, Story, I think we've had the often observed internal hang-up failure on one of our Hasselblad bodies, and the 250 millimeter lens is attached to it. The signature was the classic one of not completing a cycle, and the viewer now dark. I've consulted page 3-8 to 70 millimeter mount in the photo TV checklist and have verified that the fuse is good, that the batteries are good. I am unable to get the camera to complete cycle in the O mode, and I'm unable to free up the shutter cocking mechanism on the right-hand side of the back of the camera body as you look at the shutter assembly itself. The 250 lens, as I indicate, is mounted on the body and cannot be rotated for removal, although the lens lock push button does appear to depress normally. And if there are any other observations you need from me or anything else we've forgotten to do to try to clear this jam, we'd be happy to know about it.
Okay, Kathy, thanks very much. Max copies that. We'll get back with you.
Roger.
This is Hubble Telescope Control in Greenbelt. A little bit about the software inertial hold mode, which is the state that operators believe the telescope is in at this point. The inertial hold mode is one of the easiest to get out of.
Your present attitude, TDRS will be off the tail. Again, if you get into TDRS East and you have no comm, we'd like an item 14 on SM antenna.
Okay, Story, welcome.
Roughly at about 31 minutes.
Roger.
And the inertial hold mode is entered whenever an anomaly is detected during the normal monitoring mode. It's initiated when a performance monitor signal threshold is exceeded, or if a list of the stored commands in a computer are exhausted and it gets to a point where it cannot. It's directed to execute commands, but has no more commands to execute. The telescope attitude is inertially held to the last orientation that it was commanded in this particular mode. If entry occurs during a maneuver, the maneuver is completed and the safing system is inertially stabilized in the telescope. There aren't any subsequent adjustments in space telescope attitude that can be done while it's in this mode. All the vehicle rates are damped, and the solar arrays and the high gain antennas are all maintained at the final position that was commanded before the telescope entered into its IHM, or inertial hold mode. Currently, the telescope is in a plus V3 attitude to the sun, which is the best thermal attitude, and operators here are discussing, instead of going into a safe mode recovery, which involves going to a set safe mode attitude and then taking some time to come out of that before doing aperture door opening. Because we're in an attitude that's good for aperture door opening, they're discussing an alternative now to go ahead and go in directly into the aperture door opening once we get some good telemetry and communications with the satellite. And the next NASA Select television event will be a change of shift briefing emanating from the Goddard Space Flight Center. That'll be a briefing with the Director of Orbital Verification, Steve Terry, at 9:30 Eastern Daylight Time.
This is Mission Control Houston. We're standing by to receive some downlink television from the crew of Discovery. This is a crew choice TV opportunity. Steve Hawley had radioed down some time ago asking for TV opportunity times, and we expect to acquire some KU band capability when we acquire the tracking and data relay satellite east here in just a few minutes. So once we do acquire, about 3 minutes from now, we'll be looking for whatever the crew has to show us. Downlink expected to begin at about 8:04 a.m. Central Time.
Discovery, we're approaching the TDRS handover. After we've handed over the TDRS East, we will be able to receive TV on TDRS East. That'll be at about 31 minutes.
Okay, if you hurry, take the RMS camera when you are capable. If you get there quick enough, you'll like the view. Go ahead, Houston.
Yeah, we got the HST at sunrise there. Are you trying to get us something now, or should we?
Oh yeah, I was hoping you could get see the HST and sunrise. I wasn't sure if the timing was going to work out. When we get set up here, we were going to let you come inside if you want to do that.
Were you running the TV there for a while, Steve?
Oh Oh yeah, I was trying to point it for you, and then when the sun came up, I just turned it off.
Okay, thanks.
Yeah, I'm sorry if I messed you up. I don't know if you got to see anything interesting there or not.
We saw it. Houston, Florida.
And we're setting up a camcorder on the flight deck and orbiter CCTV on the mid deck. We'll send you flight deck first. I'll tell you what. We'll let if you're already set up for orbiter TVs, we can send you mid deck.
Okay.
And do I need to take the TV sync switch back to normal for that, or can you guys do what you need to do?
We'll take care of it, Steve. Houston for Lauren or Charlie?
Go ahead, Star.
Yeah, the FES, while you're in GG, the FES has got you about 70 degrees out in roll, and we need to do better than that for your Madagascar pass coming up in about 40 minutes. So we'd like you to terminate the FES. You can do that according to your flight plan there at 1 hour. It's just red out temp normal, FES primary A off.
Okay, you want that now then?
Yes, sir, that will be fine. And after you've done that, go B auto Vern, and that'll get you back in attitude.
Okay, we're on our way.
And we've got a good mid-deck picture.
A copy, Story. And as you can see, Kathy's setting up for some IMAX operations later on.
Okay, we've got it. And Lauren, we see you maneuvering back to attitude. Once you're on attitude, you can pick up GG again according to the checklist step 2, page 10-6.
Okay, we'll do that, Story.
Thank you.
This is Mission Control Houston. On board Discovery, Commander Lauren Shriver is now in the process of maneuvering Discovery back to the gravity gradient attitude due to the use of the flash evaporator system, which offloads supply of water from the orbiter in the form of steam, is somewhat propulsive by nature, and after
Watching y'all's got me about ready to go floating in the moker.
Roger that.
and after several orbits of FES operations, Discovery has very slowly and gradually rolled out of the gravity gradient attitude.
And Story, I guess it'll take you some reconfiguration, but as far as we're concerned, you can flip back and forth that well between the flight deck and the mid deck.
Thank you.
We got a lot of sun coming in the overhead windows on the flight deck, so I'm not sure what the picture will look like to you.
Okay.
And so as Commander Lawrence...
There's a nice pink hue down in the mid-deck. Now we got the flight deck.
Okay.
And so as Discovery continues to roll back to the gravity gradient attitude, we continue to take some live downlink television from the flight deck.
Story, I do have something to show you that you might recognize.
I can't wait.
You can find all kinds of really neat stuff in space.
Okay. Thank you, Steve.
You know what that is, I bet.
Not only what it is, but whose it is.
do you think it's worth to him to have it back? And it's still running, too.
Well, that watch gets 2 rides for the price of 1.
Absolutely. You didn't lose any salt tablets, did you?
Not that I know of.
Okay, it must be somebody else's.
I lost my comb, though.
Yeah, but that was probably several years ago. Since I was thinking of it, with reference to watch, I would like to comment that when we were down for CEIT, the crew really was impressed how clean Discovery was. And now that we're on orbit and we've really had a chance to get in and look around and take the panels off and do filter cleaning and all of that, we're still very impressed at the cleanliness of the vehicle. I suspect that the biggest stuff that we found on board, we left. We are former crews, and the Cape guys really deserve an attaboy for delivering the vehicle in such great shape.
They sure do. There wasn't a single fingerprint on a window when we flew it.
Yeah, it's really remarkable.
And we're going back to middeck now.
Okay. Story, how many more minutes of TV do you expect to have?
Oh, about 10 minutes, we think.
Okay, very good. We're going to do something here.
Story, what we wanted to do was say a little bit of well-deserved thanks to our training team who worked really so hard with us for actually quite a long time, a couple of years while I've been with the crew anyway. So we really appreciate all the long hours and late hours and all the hard work that they did. And it's really paid off, we believe. And we'd like to thank them for the little cards they gave us to read while we're here on orbit. They're very appropriate. And we'd just like to let them know that all's going well. We're feeling great, and to give Mickey our official signal.
Okay, I'm sure they're watching. If they don't happen to be right now, I will call them.
Roger.
ECOM's noticed y'all got jackets on. If you'd like it any warmer in there, let us know.
Yeah, it was kind of cool this morning story, and so we put the jackets on. It's a bit warmer now, and we're real comfortable.
Okay. Discovery, we're back on the flight deck.
Okay, we copy, and we're back in attitude, and Lauren's going to go back GG free drift.
Thank you.
Story, it looks like we're going right over Florida again. It's not quite as clear today as it was Tuesday.
Okay.
Although now looking at the overhead window, it looks like once you get north of the Cape, it clears out and it's reasonably clear all the way up the East Coast.
We're going to move outside and see what you're looking at.
Yeah, I don't blame you.
This is Hubble Telescope Control Greenbelt. The briefing scheduled on NASA Select with off-going shift Director of Orbital Verification Steve Terry has been slipped from 9:30 to 10 o'clock Eastern Daylight Time. Again, the briefing scheduled for 9:30 Eastern Daylight Time.
The TV looks like you're passing Puerto Rico there.
has been slipped to 10 o'clock Eastern Daylight Time.
That XLV is a magical attitude. Discovery, Tidris is moving over your tail right now in this attitude. A reminder, we will be LOS for a little more than half an hour, from approximately 1 hour and 1 minute to 1 hour and 33 minutes.
Roger that, Story.
And this is Hubble Telescope Control Greenbelt with the NASA Select television now originating from the Goddard Space Flight Center. The next television event on NASA Select television will be a stock change of shift briefing with off-going Director of Orbital Verification, Steve Terry. That's scheduled for 10 a.m. Eastern Daylight Time. The operators here at the Space Telescope Operation Control Center have reacquired signal with the telescope off the aft Logan antenna, and they're beginning to send commands to configure the general purpose DF-224 computer and the PSEA for a plus V3 sun point attitude. Currently, the telescope is at a plus V3 attitude and in an inertial hold safe mode. Before they can go and open the aperture door, they have to select this plus V3 attitude in the PSEA. So if the entry into the safe mode occurs, then the vehicle won't slew to a minus V1 attitude in a sun point safe mode. So they're going through a series of commands. They're about to wrap up those commands to reconfigure the computer and the PSEA to a plus V3 attitude. One of the steps in the procedures that have to be accomplished before aperture door open is the selection of the bright object detector and activation of that detector. That operators say has just happened. They've selected that, and they are getting closer towards an eventual aperture door open. We don't have a time for that open as of yet, but it is coming. And a picture on NASA Select television of the mission operations room located within the Space Telescope Operations Control Center here at the Goddard Space Flight Center. It's the heart of NASA's Hubble Space Telescope ground system. And from this room, Space Telescope project managers...
We did pick up that car. We got you for about 3 minutes, UHF only.
Okay, Story, you're loud and clear, UHF.
The same.
From the MOR, or the Mission Operations Room, Space Telescope project managers and engineers control the orbiting observatory and maintain an around-the-clock vigil from 15 different consoles. Console currently in view and on NASA Select television is actually two teams, the optical telescope assembly team to the back of the middle of the field of view, and the pointing control system team and the pointing control system engineers console.
Hey, Discovery, your training team got your thanks. They say you guys are making us very proud. Love those tortillas. And Mickey brought the message in.
Okay, that's great. Thank you very much.
Discovery, we got 1 more minute of UHF here. Pick you up over Tidris West at 1 hour, 34 minutes.
This is the Hubble Telescope control in Greenbelt. Commands have been sent up to to open the aperture door. And operators waiting for some verification that the doors are moving, that the door is moving. And an 80-second wait. And we have confirmation that the motor is running on the door, and the door is beginning to open. And we have confirmation from the stock that the aperture door is open.
This is Mission Control Houston. As Discovery is currently not in contact with the control center here in Houston, we've handed the tracking and data relay satellite system over to the telescope operators in Greenbelt, Maryland to successfully perform the aperture door opening, and we're due to acquire signal again with them in about 15 minutes. So it appears that the crew will be the last to know that they will not rendezvous, that the telescope's aperture door has been successfully opened, and that word will go to the crew in about 15 minutes when we acquire signal again through the Western satellite.
The next television event on NASA Select Television will be stock change of shift briefing with off-going orbital verification director Steve Terry, scheduled for 10 a.m. Eastern Daylight Time. This is Hubble Telescope Control Greenbelt. NASA Select Television, they're looking at over the shoulder of the pointing control system team. The pointing and control system engineer is in charge of the health and safety of the gyroscopes. And right at the aperture door open, we had an apparent rate gyro failure, and they're looking at the telemetry and the data right now to understand that better. And initial indications on the rate gyro problem are that sometime shortly after aperture door open, two of the rate gyros went down on the telescope. When that happens, the telescope automatically goes into a software SunPoint safe mode. It was already in a safe mode, and it just changed statuses and went into the next step of a safe mode. Because they're at a plus V3 attitude, the SunPoint safe mode attitude did not change, and so they're still at their current plus V3 attitude.
This is Hubble Telescope Control Greenbelt. Our next television event is a Space Telescope Operations Control Center change of shift briefing with off-going Director of Orbital Verification, Steve Terry. That briefing scheduled to start in just a couple of minutes. Again, our next television event, change of shift briefing originating from the Goddard Space Flight Center News Center, scheduled to begin in approximately, or in just a couple of minutes. This is Hubble Telescope Control, Greenbelt.
Discovery Houston, we're back with you. Tidris West. Discovery Houston, back with you through Tidris West.
Okay, we have your loud and clear story, and quick thing for ICBC.
Go ahead, Charlie.
Okay, we did get the Madagascar pass. We think Bruce got from the west coast all the way to the east coast. There was a little bit of haze down there, but we were getting, it looked pretty good, and we may have gotten some of the beginning of the Terminator. We shot it for 30 seconds on F8, and the meter, the counter went from, it's now in the 1500 to 1750 range, the footage counter. And I do have one note for them that maybe they can help us explain.
Go ahead, Charlie.
Okay, once we went back to standby disable, we were running through just to check the f-stop, and I got the footage counter, and we noticed that the f-stop was showing 2035, indicating an F3.5, and we had set F8 prior to shooting and had checked it within a few minutes of the shooting. Is there something that happens when you go to standby disable that may account for that?
we'll check on that, Charlie.
Okay, but they may just make a note of it in case it turns out that, you know, somehow we hit a wrong key or something, but we checked it twice to make sure we were at F8.
And Charlie, you do lose that indication when you go standby disable, so it sounds all right.
That's good news.
In Discovery, Hubble is open for business.
That's outstanding. Thank you, Story.
And we've not been completely released yet from a rendezvous or other work. That ought to be coming shortly. Fred Wotalik and all the Hubble family send you congratulations and appreciation for a job perfectly done.
Well, a lot of people had a lot to do with it, and we're just proud to have been part of the team that put the observatory in business.
Yes, sir.
I don't suppose they'd want to give me any time on it, would they?
I'll give you all the time you'd like, Steve-O.
Okay.
Houston, for Kathy, or anyone that can tell me what the model number of the failed Hasselblad is.
Okay, it's a ELX Story, and if you need the serial number or any other specifics, we can get that for you.
Thanks. ELX is what we're after. And you can disregard a G23 message. No acknowledgement required.
Houston Discovery with another IMAX note.
Go ahead for IMAX.
Okay, Story, we currently configured with the interior film, the ASA-25 in the camera, and we've been shooting some EMU activities and stuff like that. We have the Caribbean Pass coming up, but you guys told us to hold off on using the exterior film. I guess, is there a way that we can keep the ASA-25 and shoot the Caribbean that'll be satisfactory to them, or do they want us to download and upload the 250?
I'll get back with you, Charlie.
Okay.
Charlie, you can plan on a Caribbean with an in-bay camera.
Oh, okay, I understand. You want to take it with ICBC?
Yes, sir. And later on, we may have a word
Okay,
or two
we
for
got
you.
it. Okay, we're waiting to copy.
We don't have them now.
All righty.
This is Mission Control Houston at mission elapsed time 3 days, 1 hour and 56 minutes. Director of Orbital Verification Mike Harrington has contacted Payloads Officer Nellie Carr here in the Flight Control Room to officially release the Mission Control team and crew and Orbiter Discovery from further rendezvous EVA support.
Discovery, Houston.
Go ahead, Houston.
Okay, Steve, in STS-31, you've been released from Hubble support. It's on its own. Thanks a lot.
Okay, thank you, Story. That's great news.
And the rest of the flight plan for the day will be just as the plan we sent up to you. We know you're eating lunch right now, but when you get done and Steve-O gets free, he can stow the MPMs, power down RMS.
Okay, he copies that. Story, there's handshakes and smiles all around up here. I bet it's just that way back down there, too.
You bet.
And congratulations to you guys and everybody on Bill's team for a job well done.
Well, he's got a big smile, too. And y'all made it easy for us.
Who's buying tonight?
We'll buy when you all get back.
Okay. Okay, Houston Discovery here, over.
Go ahead, Bruce.
Yes, Story, we got the Hasselblad back in service, and we're pressing on with it. Thank you.
Okay, did it take anything special to get it going?
Just a procedure that Jeff Brimmer taught me a few years ago.
Okay. That's good news. We're 2 minutes from handover to Tidris East.
Okay, Story, we copy.
This is Hubble Telescope Control Greenbelt at 3 days, 2 hours, 13 minutes mission elapsed time. The orbital verification team here in the Space Telescope Operations Control Center is continuing to study the situation with the Hubble telescope, which is currently situated with its +3 axis, which is the top of the telescope toward the sun. The telescope aperture door is open. However, during the time that the aperture door was opening, analysts here have indicated that the motion of the aperture door opening apparently generated some rates within the gyro system that were in excess of what were expected and caused that to fail what they call a gyro test on 2 of the 4 gyros. This in turn caused the software in the telescope's subsystem computer to place the telescope in what is referred to as a software sunpoint safe mode. This is similar to the safe mode that the telescope was in at the time the aperture door was open. This basically maintains the telescope, or if it isn't already, in a sunpoint attitude with either the tail end or the top of the telescope would place the telescope in that attitude. In the case of this morning's transition to the software sunpoint safe mode, the telescope was already in that attitude, and therefore essentially there was no real action that occurred with the telescope. At this time, the telescope is safe, stable. The Hubble Telescope Control Center is in communication with the telescope and is doing some cleanup commanding, some adjustments with the telescope. Meanwhile, analysts here in the control center are taking a look at the data. We'll be gathering some additional gyro data, and then we'll be laying out a plan to go ahead and gradually bring the telescope back to normal operations. This is a procedure that takes a considerable amount of time, and it is a deliberate step-by-step process. But again, the telescope at this time is stable. The control center is in communication with the telescope, and in essence, the telescope has done exactly what it should have done under these circumstances. At 3 days, 2 hours, 16 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston at mission elapsed time, 3 days, 2 hours, 20 minutes.
We are with you on Tidris East. Got a couple notes for you.
Okay, Story, go ahead.
Okay, you can delete that flash of VAP activity that occurs around 2:48. And IMAX, I would like you to shoot the Caribbean with in-bay camera, but only if the roll is within plus or minus 45 degrees. Should not be a constraint. You've been running about 5 degrees.
Okay, and we think we're going to be in shape. We're at 3.5 now, and we got out to a max of about 9 before it started back.
Okay, we're getting TV down here.
Okay, and so they know what we plan to do. We're going to make an effort to start the camera when we actually physically get about a third to halfway through the island of Cuba, and then run it for 30 or 45 seconds if they want us to go that long to at least get Puerto Rico in.
Okay, Charlie.
This is Mission Control Houston at 3 days, 2 hours, 21 minutes. This live television coming from the payload bay cameras. This is the elbow camera on the robot arm of Discovery. Discovery orbits the Earth nose down towards the Earth. We have an opportunity to take this view of the west coast. So they cross the Gulf of California and across the Sierra Madre range. During the last orbit, crew Discovery was given the good news that the aperture door on the Hubble Space Telescope was opened as Capcom Story Musgrave radioed the crew that the Hubble is open for business at 3 days, 1 hour and 56 minutes. Call came from the stock that the flight control team here, the crew and the vehicle, Discovery, have been released from further rendezvous EVA support of Hubble Space Telescope activities. And crew's in the process now of wrapping up their midday meal and will set about to complete a nominal Flight Day 4 timeline, which will feature Steve Hawley stowing the MPMs and powering down the robot arm, repressurization of the cabin to 14.7 psi, continuing IMAX operations both in the cabin and the payload bay, and then the rendezvous breakout with the NH2 burn scheduled in just a little while. That's a height adjust burn that'll set up, deorbit, and separate from the Hubble Space Telescope. Just about 3 3/4 hours after the NH2 burn, Discovery should pass directly underneath the Hubble Space Telescope, about 2 miles lower. That NH2 burn is currently targeted for 3 days, 6 hours, 32 minutes, but as we get closer, our flight dynamics officer will be refining that time and parameters for the burn. Shortly after the NH2 burn...
Use for Charlie.
Go ahead, Story.
Yeah, the IMAX is always at your discretion, but IMAX suggests maybe starting at the southeast end of Cuba.
Okay, we'll go ahead and do that.
In Discovery, Bill Reeves and Orbit 1 team will be handing over to Milt Heflin and Orbit 2 team here.
Enjoyed it today, Story. Thanks for all the great news, and you guys get some rest.
Okay.
Hey, and Story, thanks a million also. If you see Jeff Brimmer, could you give him a call and tell him thanks?
Sure will.
This is Mission Control Houston. Shortly after the height adjust burn, or NH2, which is scheduled for just about 4 hours from now at 3 days, 6 hours, 32 minutes, a co-elliptic burn called NSR2 will be conducted to place Discovery in an orbit co-elliptic to that of the Hubble Space Telescope. And again, about 3 3/4 hours after the height adjust burn, it's expected that Discovery will pass just about at a distance of 2 miles directly underneath the Hubble Space Telescope. As the crew will get what will be perhaps their last look at the telescope before heading home. Again, the other highlights of the day yet to come are repressurization of the cabin to 14.7 psi, continued IMAX photography both in the cabin and using the payload bay camera. And we hope to continue to bring live downlink television such as we have here from the payload bay cameras. And as the crew zooms in, just leaving the field of view in the lower left-hand quadrant, the city of Brownsville, Texas. As Discovery tracks out over the Gulf of Mexico. Discovery's cameras providing a wide-angle comprehensive view of the South Texas coast from Brownsville, in the middle of the frame, clear up to Corpus Christi. And very evident in the frame now that severe weather system that has affected the state of Texas and the Gulf Coast region over the last few days, spreading well into the Gulf of Mexico and approaching.
This is Mission Control Houston. Discovery now passing over Central South America in its payload bay to the Earth, nose south attitude, as seen on the computer graphic. The crew aboard Discovery will shortly maneuver the vehicle to its IMU align attitude. That's the attitude used when we align the inertial measurement units aboard the orbiter. That IMU align maneuver scheduled to begin shortly after 4 days, 6 hours, 30 minutes mission elapsed time. A few moments ago, Capcom Jim Voss notifying the crew that they could expect an alarm on their PPCO2 limit. That's the carbon dioxide limit inside the cabin.
Go ahead, Kathy.
Yeah, Jim, if the IMAX folks are still around, I can give you a bit of a synopsis of what we think we've accomplished today.
We're ready to copy.
Okay, we did get the ICBC Sri Lanka pass as requested, and it looked real good on board, so we hope they'll be happy with it in the lab. We got a South Africa, tip of South Africa handheld pass with a 60mm lens. I believe that was about straight on 30 seconds. And we've been working real hard in and around the cabin stove period here on some of the high priority in-cabin scenes. And I think we've accomplished all of the high priority objectives they set out, and by my last count there were 7 different scenes that we had gotten accomplished through the afternoon here.
Okay, that sounds good. Do you still want that closest time of closest approach for South Africa on Rev 65?
Yeah, we would still like to do that. We're not positive how much footage is remaining in the bay camera, but we'll give one a try if we can get to TCA.
Okay, that time is 7 hours and 57 minutes.
I understand. 7 plus 5, 7.
That's correct. And Kathy, that's not the TCA, that's the AOS. So that'll be the first opportunity, and you can pick your closest approach point.
Okay, Jim, I apologize for stepping on you there, but I understand it's AOS vice TCA. Thank you much.
And Kathy, I seem to have stumbled onto the Fred Gregory geography approach here. That's South America, not South Africa.
Oh, that continent. Okay.
Roger.
I think we've been up here long enough we know the difference, so we'll try.
I thought you might figure that one out.
Well, we might have had a short debate about whether you really meant the MET or you really meant the continent.
And this is Mission Control Houston. Discovery now maneuvering to the IMU align attitude. That is the attitude which will be used to align the inertial measurement units aboard the orbiter. Once in attitude, the IMUs will be aligned using the star trackers, which will select stars in the field of view to basically tell Discovery where it is and keep it in its proper attitude.
And Discovery, we're off the tail now, so we may have some bad comm for a little while.
Roger, Jim.
Discovery Houston, just a heads up, it looks like the last KU band that we're going to have is at 7 hours and 40 minutes today. And we'll probably have you stow the KU band after that, sometime after 8 hours MET. We'll give you an exact time later on, but wanted you to know when the last opportunity for downlink was.
Okay, we copy.
Discovery Houston, we're about to go LOS. We'll see you back on the other satellite at 7:02.
Roger, and did you guys get the IMU line and COAS data?
That's affirmative, Lauren. We did get the data.
Okay, good.
This is Mission Control Houston. We've lost signal with Discovery through the tracking and data relay satellite east. We'll acquire the signal on the western satellite in about 5 minutes and 15 seconds. Discovery now just beginning orbit 65 on its way crossing the southern part of India. Now about 2 hours and 2 minutes away from beginning the official sleep period for the crew. The latest figures for return home tomorrow are that the deorbit burn will occur at 5 days, 0 hours, 3 minutes. That translates to about 7:37 a.m. Central Daylight Time. That deorbit burn will last for approximately 4 minutes, 48 seconds. And will change Discovery's velocity by 572 feet per second. With an on-time deorbit burn landing at Edwards Air Force Base, California, scheduled for 5 days, 1 hour, 15 minutes. Translates to 8:49 Central Daylight Time, 6:49 Pacific Daylight Time, Sunday morning. In the last several hours, the crew has been stowing equipment aboard the orbiter for the return home tomorrow. That cabin stow was scheduled to be completed by 4 days, 6 hours. The two remaining items, cleanup items, before going to bed will be to stow the KU band antenna used to downlink television from the orbiter, and also to do a supply water dump. And that supply water dump will either be done through the nozzles or through the FES, which is the flash evaporator system. The difference being the FES moves a little slower and translates that water to steam. And that supply dump is scheduled for 4 days, 7 hours, 30 minutes. Now 1 hour and 59 minutes away from putting the crew to bed. 1 minute, 50 seconds away from acquiring signal on the western satellite. And we're at a mission elapsed time of 4 days, 7 hours, 1 minute. This is Mission Control Houston.
Discovery Houston, we're back with you, and we have your supply water dump numbers when you're ready.
Yeah, we kind of figured you would. Go ahead, please.
Okay, that dump schedule for 7 hours and 30 minutes. We'd like for you to dump supply water tank Bravo to 45%. That's 45%. And the dump duration will be approximately 16 minutes, 16 minutes.
Okay, we understand. Bravo to 45%, and it should take about 16 minutes.
That's affirmative.
This is Mission Control Discovery.
And Jim, we go to do that as soon as we get established in attitude.
Yeah, we're checking, Steve. And Steve, as soon as you're in attitude, you're go to do the supply water dump.
Okay, thanks a lot.
This is Mission Control Houston. That call giving the crew the okay to begin the supply water dump. Once the orbiter is in the attitude, Discovery currently maneuvering to the water dump attitude. The water dump will be from tank B, which is currently at 62.3%. The crew's instructed to dump that tank down to the 45% level, and the duration of that water dump will be for about 16 minutes.
Houston Discovery.
Go ahead, Charlie.
Jim, I saw some uplink activity on SM. I was wondering if it would mess you up if I did a checkpoint.
Stand by, Steve. Yeah, there's no problem with you doing your checkpoint now, Steve.
Okay, thanks.
Discovery, I have one more Big Max update for you. It looks like the latest weather shows that there's some cloud cover over the western coast south of 33 degrees. It does look clearer towards the Argentine side, but the shot is your choice. And the IMAX folks, they say lots of thanks for all your hard work today.
Okay, Jim, we copy that, and that observation squares with what we saw looking south from our last pass. And we'll just give it a look out the window and see what we think. And we sure enjoyed working with the IMAX guys. If we can bring across via their footage 10% of the amazing sights that we've seen during this flight, we'll be very proud, and we'll be very honored that so many people will get to share in all the joys and excitement that STS-31 has been. So thanks to all the IMAX guys. I know they've been working hard too.
Okay, Kathy.
This is Hubble Telescope Control Greenbelt. 4 days, 7 hours, 25 minutes mission elapsed time. The next television event is a Space Telescope Operations Control Center change of shift briefing from the Goddard Space Flight Center with off-going Director of Orbital Verification Mike Harrington. That activity is scheduled for 3:30 p.m. Central Time, 4:30 p.m. Eastern Time today. It will occur from the News Center at the Goddard Space Flight Center. This is Hubble Telescope Control, Greenbelt. This is Hubble Telescope Control, Greenbelt, at 4 days, 7 hours, 26 minutes mission elapsed time. The orbital verification team here has been going through the initial steps in preparation to attempt to reactivate one of the two telescope high-gain antennas, high-gain antenna number 1. This process has been going a little slower than had been planned. The team began by tightening down some of the tests or limits on torque that could be placed on the high-gain antennas before triggering entry into safe mode as a precautionary measure, and then commanded the electronics for the high-gain antennas on. In addition to that, they began attempting to drive high-gain antenna number 1 to the 0 position so that a stored program which has now been loaded onto the spacecraft can approximately 2 hours after, in approximately 2 hours, could pick up and begin controlling the high-gain antenna. This was a health and safety load that basically maintains the spacecraft in operational configuration. The next step was to well, correction, in the process of attempting to drive high gain antenna number 1 to the 0 position, commands were also sent to maintain high gain antenna number 2 in its current position. Controllers here noticed as they were going through that process that the torque on high gain antenna number 2 was building slightly, and so they disenabled the control law, which basically stopped the process, and scratched their heads for a bit. They recently attempted to make a second run at driving high gain antenna number 1 to 0 position, and at this attempt also attempted to drive high gain antenna number 2 to the 0 position. During this attempt, again, it was noticed that some of the torques on one of the axes of one of the antennas was building slightly, and as a precautionary measure, a command was sent to the spacecraft to stop the activity. So at this point, we're taking a look at the data, and the orbital verification team will be making a decision as to where to go from here. But otherwise, the spacecraft is operating nominally. We are continuing to command and receive data through the low gain antenna system, and other systems are all reporting, system operators are all reporting that the subsystems are performing as expected. At 4 days, 7 hours, 29 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston. Discovery now out in the Pacific Ocean on orbit 65. Ecom officer reports that the water dump has completed. Tank B is now down to the 45% level, and reports that that dump looked good.
This is Hubble Telescope Control, Greenbelt. 4 days, 7 hours, 36 minutes mission elapsed time. Recapping the events that just occurred, we were sending some commands to the telescope, or had sent some commands to the telescope to drive both high gain antenna 1 and high gain antenna 2 to the 0 position, which was designed to allow high gain antenna number 1 to be in a position for the onboard computer program to begin using that antenna to communicate through the tracking and data relay satellite west somewhere around 6 p.m. Eastern Time today. During that activity, the orbital verification team noticed some data indicating that the torques on the x-axis of high gain antenna number 2, and that's the antenna with which we had some difficulty yesterday, were beginning to build. And as a precautionary measure, the orbital verification team decided to simply send a command that would kill the activity in progress and basically stop the process of attempting to reposition the high gain antennas. That was done successfully. No adverse effects on the spacecraft whatsoever. And at this time, the orbital verification team is preparing to replace the onboard software load, basically health and safety load is what it's referred to as, with a new load that will not contain the material or the information that will attempt to drive the high gain antennas. This will just basically back us out of that and give the team an opportunity to look at the situation as it stands now. 4 days, 7 hours, 38 minutes mission elapsed time. This is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston. We're expecting some unscheduled shuttle television from Discovery when we acquire the signal at about 4 days, 7 hours, 40 minutes. This is Mission Control Houston. Discovery now crossing the equator in the Pacific Ocean. Now taking views from the elbow camera on the remote manipulator system arm, looking forward. You can see the flight deck windows of Discovery. In the upper right-hand corner of the screen is the KU band antenna on the right-hand side of the orbiter. KU band antenna is the antenna used as the television coverage for the pictures we're seeing. That antenna is scheduled to be stowed before the crew goes to sleep this evening, now about an hour and 15 minutes away.
Houston Discovery.
Go ahead, Lauren.
Yes, did you say that we had done our last KU band now?
We have it right now, Lauren, and we've got it until 8 hours and 4 minutes MET. In fact,
Okay, well, hold on.
In fact, we're enjoying Payload Bay downlink right now, looking at the Earth. And Discovery for Lauren. We have 2 messages coming on board, Lauren, and then we're going to stow the KU band tonight. We would like to watch that stowage, so you have the option of stowing it sometime between 8:04 when we lose KU and 8:20 when we lose the TDRS, or after we get you back at 8:46 between then and when you go to bed at 9 hours.
Okay, Jim, we understand. Lauren's preference would be to take the early opportunity.
Okay, then we'd appreciate you stowing it between 8:04 and 8:20.
Welcome.
And your last 2 KU messages should be on board in the tags machine.
Okay, we'll check.
And it sounded like Kathy recognized one of those was for her. Discovery Houston, one thing about your KU band antenna stow, we would like for you to omit the first step, the tags deactivation. We'd like for you to do that tomorrow. And the reason is so that we can watch it through the night to see if we have a repeat of the anomaly that we had after we first activated it. And then I've got your pre-sleep cryo config when you're ready.
Okay, we copy omit tags deactivation, and stand by a second. Steve is getting a pad for the cryo config.
And Jim, we're ready. Go ahead.
Okay, Steve, your pre-sleep cryo config we'd like for you to perform after the fuel cell purge. Panel R1, O2, H2, manifold valve, tank 2, 2 switches closed, talkback closed. O2, H2, tank 3, heaters alpha, 2 switches to auto. O2, H2, tank 1, heaters alpha, 2 of them to off. Over.
Okay, Jim, let me see if I got it here. O2, H2, manifold valve, tank 2 to close, and that's 2 switches, talkback closed. O2, H2, tank 3, heaters alpha, 2 switches to auto. O2, H2, tank 1, heaters alpha to off.
That's a good readback, Charlie.
And Houston Discovery, Jim, you guys are just treating me too good. You do great work.
We try to please.
This is Mission Control Houston, camera A now zooming in on the elbow camera on the remote manipulator system arm, looking at the tail of Discovery. This downlink television should be the last of the mission from Discovery, as the crew was informed moments ago that when this downlink television is completed, They were given the go to stow the KU band antenna, which gives us the ability to take television from the orbiter. We're expecting to get this downlink for another 5 minutes or so, and therefore a change of shift briefing from the Space Telescope Operations Control Center in Greenbelt, Maryland has slipped for about 15 minutes, and as soon as this downlink is completed, we will be switching the satellite to Goddard Space Flight Center for that briefing. Now about 1 hour and 2 minutes away from putting the crew of Discovery to sleep. Discovery now in the South Pacific, approaching the west coast of Argentina on orbit 65. Headed for a landing tomorrow morning at Edwards Air Force Base on orbit 76. Weather officer reported a while ago that the weather at Edwards at landing time is expecting a front to move through, although not carrying any wet weather. It is, however, carrying some winds, and the winds are expected to be marginal at the time of landing. However, the timing of that front moving into the Edwards area is the question right now, and that weather will be monitored throughout the evening on the planning shift. This is Mission Control, the elbow camera now being placed into its parking position for return home tomorrow. Now looking from camera A to make sure that that elbow camera is in the correct position. Now looking at the coast of South America as Discovery crosses from an altitude of 334 nautical miles.
Discovery Houston, I have a couple of questions about your COAS cow for whoever mounted it today.
We're sorry, but you've got the wrong mission here. Please place your call again later.
Discovery Houston, we'd like to talk to whoever was doing your COAS cow.
Okay, I wasn't Hooter, I'm sorry.
Okay, go ahead, Jim.
Negative, I know where he is. Okay, Charlie, I think the plus COAS cow position was not repeatable today. We've seen some problem with this vehicle before. There was a 0.6 degree movement between the two cows today, and that's one reason I guess we wanted to do that. I have a couple of questions for you. First of all, can you give us any insight into any problems you had in mounting the COAS at the plus X position?
I mounted it both times and didn't have any problems at all.
And did you have any
And we're starting on KU antenna still.
Okay. Did you have any visibility problems through the window with the COAS?
The first time, for some reason, the star was more difficult. Seemed to be more difficult to see when we did it. You know, 3 of us looked at it and verified that it was the same star. I can let Lauren talk to you, but that was the only comment that we had, was that it seemed to be, you know, I can't explain why, but it seemed to be much more readily apparent to us tonight.
Okay, yeah, the shot groups were good on both of them. All of the marks you took were pretty close together. It was just a fairly big difference between the group from this morning and the group from tonight. One last question was, did you rotate the COAS barrel between the two cows, or did it remain in the same position?
We rotated the barrel between the two cows because we had reinstalled it in the -Z slot for some filming.
Okay, we copied that. If we have any other questions, we'll get back with you later. Thanks.
Okay. Jim, the other thing that Lauren is pointing out is that there were two different people that did it each time. Lauren did the one earlier, and I did the one this evening.
Roger, and I think that all of the marks were perfectly okay. It was just apparently some misalignment that we've seen before, and we're just trying to investigate it while it's still fresh in your mind to try to give us some insight into why we keep getting this misalignment.
Okay, we copy.
This is Hubble Telescope Control Greenbelt at 4 days, 8 hours, 7 minutes mission elapsed time. The next television event will be the Space Telescope Operation Control Center change of shift briefing with off-going Director of Orbital Verification Mike Harrington. That briefing scheduled to begin in about 3 minutes at 3:45 p.m. Central Daylight Time, originating from the Goddard Space Flight Center. This is Hubble Telescope Control Greenbelt.
And Houston Discovery for IMAX.
And they're listening, Charlie.
Yeah, I guess I have bad news. We had a great pass over South America. The bad news is I think we had about maybe 5 seconds worth of footage left because the door came open and we had about 5 seconds or so and then the door closed, so I don't think that's going to be usable to them.
Okay, we copied that. Maybe you got lucky and you'll have 5 seconds of great footage, though.
Well, let's hope so. And Jim, if you can ask IMAX if they would verify the deactivation, we have completed just like their verification.
Okay, we'll check with them. And Charlie, IMAX has no insight into the deactivation, so we'll have to take your word for it.
Yeah, Jim, thanks very much. I wasn't sure. I just wanted to make sure that they didn't have anything else they wanted us to do other than the standard deact from the Q card.
No, they don't, and they copied that you've shut it down.
Houston Discovery and preparing for payload bay door for KU band antenna stowage. We've got camera Charlie trained on the area where the KU band will be coming in if you want to take it, or we can record it. We will record it on board.
Thanks.
We're recording it on board.
Okay, thanks, Bruce. We're in blockage right now, so we'll have to see it later. Discovery Houston, we're going to be LOS in 1 minute. We'll be back with you at 8:46, and we saw a good stow on the KU.
I copy, Jim, and you may have noticed we got a display switch left message right as we took the KU to off.
We copied that,
Okay,
Charlie.
and it came with the BCE bypass, which we expected.
Roger, we copied that.
BCE bypass, but not the display switch left. Display switch aft, I'm sorry.
Roger. And Charlie, we think that's not a problem. We'll continue to look at it and we'll let you know.
Okay, thanks very much.
This is Mission Control Houston at 4 days, 8 hours, 40 minutes mission elapsed time. Back now here at the Johnson Space Center in Houston. Discovery now on orbit 66. We're still LOS with the crew. That's loss of signal. We will acquire the signal on the western satellite in about 5 minutes and 20 seconds. This is Mission Control Houston. We're now about a minute away from acquiring signal with Discovery through the Tracking and Data Relay Satellite West. When we do acquire a signal, we'll be about 13.5 minutes away from beginning the crew's official sleep cycle. It's been a very quiet day as the crew has been busily readying Discovery for the trip home tomorrow, including stowing the all equipment that they took out during the flight to support Hubble Space Telescope deploy and the mid-deck experiments. All stowage is complete aboard Discovery. Flight Director for the Orbit 2 shift, Milt Heflin, currently polling the room for final messages that would be delivered to the crew before putting them to sleep.
Discovery, Houston, we're back with you.
Loud and clear, Jim.
Discovery, Houston, we have a couple of things for you before we put you to bed.
Okay, just a second, Jim. Okay, Jim, we're ready. Go ahead.
Okay, Steve, first of all, an HST summary. It looks like the Hubble Space Telescope has recovered from the safe mode, and the overall health of the spacecraft and its instruments is excellent. The stock is still working, though, to reestablish communication via the high-gain antennas. They expect to get that problem resolved. The only thing we see left on your pre-sleep activities is the cryo configuration. And I have one oversight to correct on message number 49. 11 Delta should read, "Who besides Galileo would be proud of your work?" And we have one status request from you, do you have any inside IMAX film remaining?
Stand by, we do have some, Jim, and let us give you a count.
Okay.
Houston, Discovery.
Go ahead, Discovery.
Okay, Jim, the IMAX film remaining summary as of now is we have an indoor mag loaded on the camera with 2 scenes on it. We have 1 full outdoor spool and 1 full indoor spool unused.
Okay, Kathy, thanks. They just wanted to do some planning in case the weather turns bad.
Roger that, we were thinking the same.
Okay, thanks. And Milt Heflin and the entire Orbit 2 team have enjoyed the beautiful views of our Earth that you've sent down to us, and it's been our pleasure working with you on this mission. We'll be turning over to the planning team in a little while and let them watch you through your last night on orbit.
Well, Jim, thanks for those kind words, and we would like to say on behalf of all the crew that we've enjoyed working with you, and it was some kind of mission for us up here. We would hope that the Marvels can pick up their game somewhat in the future, but we realize, sometimes miracles are hard to come by. But anyway, to everybody down there on your team, thanks a whole bunch from us.
Okay, Lauren, thank you to you. And we'll look forward to seeing you back at work on Monday.
That's supposed to be our day off, but we'll see.
This is Mission Control Houston at 4 days, 9 hours, 2 minutes mission elapsed time. The planning team now on station in the control room to take a handover from the Orbit 2 team. Planning team will watch over the crew of Discovery for their last night on orbit, with landing still planned for 5 days, 1 hour, 15 minutes, or 8:49 a.m. Central Daylight Time, 6:49 a.m. Pacific Daylight Time. Final good nights going up to the crew moments ago with a couple of final little cleanup items, including their configuration for their cryogenics aboard the vehicle for the night, and to get a report on how much IMAX film was left in the event that weather wave off keeps the crew up for another day and gives them some other opportunities for taking some IMAX photography tomorrow. This is Mission Control Houston. Our next television event is a change of shift briefing scheduled with off-going Orbit 2 Flight Director Milt Heflin. That briefing is currently scheduled for 6 p.m. Central Daylight Time. That's in Building 2, Room 135 here at the Johnson Space Center. Any news media interested in taking part in that briefing should notify the newsroom at area code 713-483-5111. This is Mission Control Houston. Our next television event scheduled a change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin has been canceled. Repeating, that change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin has been canceled. This is Mission Control Houston. Discovery now passing off the east coast of South America out into the South Atlantic Ocean on orbit 66. Planning team nearly completed with their handover and will shortly take the reins from the Orbit 2 team on the final night of Discovery's flight. The crew now been asleep for almost an hour, or been officially into their sleep cycle for almost an hour, and they're scheduled to wake up in about 7 hours and 6 minutes from now. We're currently at a mission elapsed time of 4 days, 9 hours, 53 minutes. This is Mission Control Houston.
This is Mission Control. Our next television event, a change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin, has been canceled. Again, the change of shift briefing with off-going Orbit 2 Flight Director Milt Heflin has been canceled. Here in the control center, members of the planning shift team of flight controllers have taken over and relieved their Orbit 2 counterparts. Aside from monitoring Discovery systems overnight as the crew sleeps, work will focus here in the center on reviewing plans for tomorrow and the spacecraft's return to Earth. Also, weather briefing will be held at one point during the night as we continue to watch the weather closely for tomorrow's planned landing time. Another activity will be planning in case there is a problem with weather and we do have to wave off from our planned landing. We will develop a plan for the crew's activities in that case. At 4 days, 10 hours, 7 minutes mission elapsed time, this is Mission Control Houston. This is Mission Control Houston. Our next television event will be a replay of Flight Day 5 activities. That's scheduled to begin at 7 p.m. Central Daylight Time, or 4 days, 11 hours, 26 minutes elapsed time. The replay will be about 8.5 minutes long, and again, that will begin at 7 p.m. Central Daylight Time. This is Mission Control Houston. We have an adjusted time on our replay of Flight Day 5 activities, including the crew's press conference today. We'll replay those activities at 7:15 p.m. Central Daylight Time, or 4 days, 11 hours, 41 minutes mission elapsed time, and that will be about a 45-minute long replay. Again, that will be a replay of Flight Day 5 activities at 7:15 p.m. Central Daylight Time, and it will last about 45 minutes. This is Mission Control Houston at 4 days, 11 hours, mission elapsed time. Here in Mission Control, members of the planning shift are going through messages for the crew to be sent up to Discovery prior to their wake-up tomorrow. Currently on board Discovery, the crew's been asleep for about 2 hours. All systems are functioning normally. This is Mission Control Houston. Our next television event will be a replay of Flight Day 5 activities. That will begin at 7:15 p.m. Central Daylight Time and be about a 45-minute long replay. Again, that will be a replay of Flight Day 5 activities, including the crew's press conference held today, and that will begin at 7:15 p.m. Central Daylight Time. Currently in Mission Control, members of the planning shift flight control team are working on messages for Discovery in the morning. Work tonight centers around planning for the possibilities in case Discovery's planned landing tomorrow is detained due to weather. We plan out timelines in case of that. In that event, the crew is preparing a message for the crew in case we could get more IMAX motion picture targets. Also, we have a timeline we're preparing for the crew to follow in case they have to back out of a possible landing. And also an Earth observations photography list which we can send to the crew. There are two opportunities for deorbit burns tomorrow. First on orbit 75 will be at 7:37 a.m. Central Daylight Time, and a one orbit late opportunity will be on orbit 76 at 9:22 a.m. Central Daylight Time. The nominal end of mission is the 7:37 a.m. Central Daylight Time deorbit opportunity with a landing at Edwards Runway 23 at 8:49 a.m. Central Daylight Time, or 6:49 a.m. Pacific Time. Currently, we're about 6 hours from awakening the crew of Discovery. That will occur at 12:34 a.m. Central Daylight Time tomorrow morning. At 4 days, 11 hours, 7 minutes, this is Mission Control, Houston.
This is Hubble Telescope Control Greenbelt at 4 days, 11 hours, 10 minutes mission elapsed time. Controllers here in the Space Telescope Operations Control Center continue to uplink various health and safety loads to the Hubble Space Telescope, keeping the spacecraft in a safe and healthy mode, that while other members of the orbital verification team here in Greenbelt, as well as analysts at the Huntsville Operations Support Center at the Marshall Space Flight Center in Alabama, continue to look at ways in which to gain utilization of the telescope's high-gain antennas. Those antennas, of course, are needed to proceed with the orbital verification of the spacecraft. The telescope has been without its high-gain antenna usage since the failure of a torque limit test placed the spacecraft in a safe mode early yesterday morning. We are currently out of that safe mode condition, and the spacecraft is in a safe and healthy condition. However, we are not able to utilize the high gain system as of this time. All communications both to and from the spacecraft are going through the telescope's low gain antenna system. Additionally, there are plans being put in motion to try to dump some of the engineering data from the spacecraft over one of the ground stations and be able to study that data to determine if it would help in the analysis of the high gain antenna problem. The spacecraft itself, subsystems all in good working order. Controllers continuing to update the attitude of the spacecraft through fixed head star tracker mapping runs, as well as perform the low gain antenna management. All that a part of the health and safety loads that are being sent up to the spacecraft at this time. At 4 days, 11 hours, 13 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston. Our next television event this evening will be upcoming in about 15 minutes and will be a replay of Flight Day 5 activities on board Discovery today. That will include a crew press conference held during the day, and that will begin at 7:15 p.m. Central Daylight Time. That replay should last approximately 45 minutes. This is Mission Control Houston at 4 days, 11 hours, 39 minutes mission elapsed time. Here in the control center, all things are going smoothly as they are on board Discovery. Currently, we're about 5 hours and 20 minutes away from crew wake up for Flight Day 6, the day that Discovery is scheduled to return to Earth. Currently, we're looking at a landing time in the morning of 8:49 a.m. Central Daylight Time on Edwards Runway 23. Flight controllers here are keeping a close eye on the weather. Strong winds are predicted at Edwards tomorrow. However, our current predictions are that the runways are still go. Our next television event will be a replay of Flight Day 5 activities at 7:15 p.m. in about a minute. That will be starting momentarily. Included in that replay will be wake up of the crew on Flight Day 5, crew conference, press conference held today, and views of Earth from the payload bay cameras of Discovery. This replay will last approximately 40 minutes. This is Mission Control Houston at 4 days, 12 hours, 24 minutes into the flight of Discovery on STS-31. The crew is currently asleep, about 4.5 hours now until we wake them up. Discovery currently is about halfway through its 68th orbit. Everything has been very quiet tonight. Flight controllers here are watching the weather for tomorrow's landing opportunities. Our landing opportunity, our prime opportunity that we are currently aiming toward is an 8:49 a.m. Central Daylight Time touchdown at Edwards Air Force Base Runway 23. Plans are in work here, though, for all types of possibilities, one of which could be a wave off tomorrow if strong winds at Edwards force to that. And planning tonight consists of what will be done in the event of that wave off. The crew will have plans to film some targets on Earth with the IMAX motion picture camera if entry is delayed. Also a list of Earth observations, photography targets, interesting geological and oceanographic features is being prepared. Flight controllers are also reviewing and double-checking procedures for entry. The current forecast for Edwards tomorrow morning at landing time is winds out of the west at 17 knots, gusting to 25 knots. However, on runway 23, those winds shouldn't pose a problem for the orbiter. Flight controllers here are watching the weather, though, and we are expecting an updated forecast from the Spaceflight Meteorology Group located here at the control center shortly. At 4 days, 12 hours, 26 minutes mission elapsed time, this is Mission Control Houston. This is Mission Control Houston at 4 days, 12 hours, 54 minutes mission elapsed time. Flight controllers here have just completed a weather briefing supplied by the Spaceflight Meteorology Group for Planning Shift Flight Director Lee Briscoe. The forecast for Edwards for tomorrow's landing opportunities remain about the same. winds are forecast to be out of the west at 18 knots, gusting to 25 knots. Visibility is expected to be 7+ miles, with only scattered and broken clouds. For runway 23, that is within the wind limits for Discovery. Runway 23 would give us a strong headwind for landing, but under the 25-knot headwind limit for the orbiter. However, winds are, as a front passes through Edwards, winds are expected to increase throughout the day. And for the second opportunity, which would have a deorbit burn at 9:22 a.m., they're expected to be quite a bit higher, at 20 knots, gusting to 30 knots, and have turned more from the north. Those stronger winds are expected to prevail throughout Monday for opportunities on Monday also. However, the weather for our prime landing opportunity tomorrow that we're currently looking at appears within limits and to be fairly good. Currently, we're about halfway through the crew's planned to be final night in space. Wake up this morning will be at 12:34 a.m. Central Daylight Time, approximately 4 hours from now. At 4 days, 12 hours, 57 minutes mission elapsed time, this is Mission Control. This is Mission Control Houston at 4 days, 13 hours, 28 minutes mission elapsed time. Again, a summary on the latest weather forecast as given to Planning Shift Flight Director Lee Briscoe here in the Control Center. Weather for tomorrow's scheduled landing time of 8:49 a.m. Central Daylight Time currently is for slightly strong winds, fairly strong winds at Edwards out of the west, southwest, 18 knots gusting to 25 knots. 2 cloud decks are forecast, one at 12,000 feet scattered, one at 20,000 feet broken, with visibility of 7+ nautical miles. The planned runway is runway 23 at Edwards Air Force Base. That's a lakebed runway. The person in charge of taking the weather data provided to the control center and converting it into what its effect is on the orbiter is the flight dynamics officer. According to the flight dynamics officer, or FIDO as he's called in the control center, that first opportunity with winds at Edwards out of the west-southwest, 18 knots gusting to 25 knots, would create a headwind for Discovery of 17 knots gusting to 24 knots, and a right crosswind of 6 knots gusting to 8 knots. That headwind is within Discovery's flight rule limit of 25-knot headwind, of no headwinds greater than 25 knots, and no crosswinds greater than 15 knots. However, we do have a one-orbit late opportunity tomorrow also, for which the winds are forecast to increase to 20 knots gusting to 30 knots, and to turn more from the north as a front moves through Edwards. For that opportunity at this time, all the runways are forecast to be out of the headwind and crosswind limits. The outlook on Monday at Edwards appears also to retain the 20 knots gusting to 28 knots high winds, also from the north, with runways still predicted to be out of limits at this time. Although on Tuesday, weather at Edwards is very favorable in the forecast. At the current time, however, runway 23 is forecast within limits, though, and all actions are proceeding toward a deorbit burn tomorrow at 7:37 a.m. on orbit 75 and a landing at 8:49 a.m. Central Daylight Time on orbit 76. As tomorrow's landing opportunities has been characterized by Planning Shift Flight Director Lee Briscoe, it's almost threading the needle on coming in on the first opportunity, and with the front moving through, weather forecasters are going to be watching the front closely to see if it retains the current speed it's moving at and does approach Edwards at the time that they forecast it to come in. Currently on board Discovery, the crew is asleep. Cabin temperature is about 75 degrees Fahrenheit. Humidity is very low at 29.6%. The cabin's been repressurized from the 10.2 pounds per square inch it was at for several days during Hubble Space Telescope deploy, and while Discovery waited on call in case of a problem with the telescope. It's now at 14.76 pounds per square inch, sea level atmospheric pressure on Earth. Discovery has just started orbit 69, currently over Africa. We're not expecting any more live television from Discovery for the rest of this mission. The KU band antenna was stowed earlier today. That's the antenna used for transmission of television to the Tracking and Data Relay satellite and then to the ground. It's nominally stowed the day before entry. At 4 days, 13 hours, 34 minutes mission elapsed time, this is Mission Control, Houston.
This is Hubble Telescope Control, Greenbelt at 4 days, 14 hours, 26 minutes mission elapsed time. The next scheduled television event, the stock change of shift briefing with Director of Orbital Verification, Ron Schlagheck, has been canceled. That briefing was to originate from Goddard Space Flight Center. Again, the stock change of shift briefing with Ron Schlagheck, Director of Orbital Verification, that briefing canceled. This is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston at 4 days, 14 hours, 40 minutes mission elapsed time. Discovery currently on its 70th orbit, passing over the South Pacific. Crew's been asleep for about 5 hours and 45 minutes. We'll awaken them at 12:34 a.m. Central Daylight Time tomorrow. Here in the control center, members of the planning shift, the overnight shift, are busy reviewing morning messages to the crew. Those messages concern slight updates to their entry plans tomorrow that have been double checked, and plans for the possibility of a wave off if weather delays entry past tomorrow. If things are waved off, then the crew will have an opportunity to film more Earth targets with the IMAX motion picture camera, and also photograph with Hasselblad cameras for Earth observations targets, such as geographical features and interesting oceanographic features. The weather is one of the concerns for tomorrow, but at this time all plans are proceeding toward a deorbit burn at 7:37 a.m. Central Daylight Time tomorrow on orbit 75, and a landing at 8:49 a.m. Central Daylight Time on runway 23 at Edwards Air Force Base. The current weather predicts some strong winds at Edwards for landing time. The deorbit burn at 7:37 a.m. is the first of two opportunities Discovery will have to land tomorrow. If that first opportunity is waved off, there's a one orbit late opportunity, which would have a deorbit burn at 9:22 a.m. The most current forecast for runway 23 at the landing time of 8:49 a.m., the opportunity we are aiming at, is that Discovery would encounter a headwind of 17 knots gusting to 24 knots and a right crosswind of 6 knots gusting to 8 knots. The winds at Edwards are forecast to be from the west-southwest at 18 knots gusting to 25 knots and to increase quickly following Discovery's touchdown at 8:49 a.m. However, the current forecast does have the headwinds and crosswinds within limits for Discovery. It's been a quiet night in Mission Control with flight controllers just busy reviewing entry preparations. No problems on board Discovery. All systems are functioning well. At 4 days, 14 hours, 44 minutes mission elapsed time, this is Mission Control, Houston.
The next scheduled television event, the stock change of shift briefing with the off-going Director of Orbital Verification, Ron Schlagheck, has been canceled. That was a briefing that was going to generate from the Goddard Space Flight Center. Again, the off-going Director of Orbital Verification change of shift briefing with Ron Schlagheck has been canceled.
This is Mission Control Houston. Our next television event will be awakening of the crew of STS-31 for their return to Earth on Flight Day 6. And that's scheduled for 12:34 a.m. Central Daylight Time. Again, crew wake up this morning will be at 12:34 a.m. Central Daylight Time. Here in the Control Center, members of the planning shift are continuing to review messages for Discovery for tomorrow morning. Those messages include an entry summary, which details all of the minor problems which have been seen in Discovery systems during the flight. Those problems are very few, and there is really no impact from the ones that have been seen so far. Also included will be plans for Discovery's crew in case weather at Edwards causes a problem tomorrow and we have to wave off from landing. In that event, there are some IMAX motion picture targets which the crew will be asked to film during the day, and also Earth observations photography targets which the crew will photograph with Hasselblad cameras. Currently, Discovery is finishing up its 70th orbit. We're about exactly 56 minutes from wake up. And all plans are going ahead for a deorbit tomorrow at 7:37 a.m. Central Daylight Time and a landing at Edwards Runway 23 at 8:49 a.m. Central Daylight Time. Current weather for those landing opportunities shows strong winds at Edwards of 18 knots gusting to 25 knots out of the west-southwest, and on Edwards Runway 23 that computes to a headwind of 17 knots gusting to 24 and a right crosswind of 6 knots gusting to 8. Those winds are still within limits for Discovery's landing. Although they are expected to increase shortly after the touchdown time, depending on the speed with which a front that the Spaceflight Meteorology Group here in the Control Center is watching move through California at this time. For Discovery, it's been a very quiet night. Flight controllers here have spotted no problems with the systems they've been monitoring. At 4 days, 16 hours, 5 minutes mission elapsed time, this is Mission Control.
This is Hubble Telescope Control in Greenbelt, Maryland. We're at MET 4 days, 16 hours, and 10 minutes. The Hubble Space Telescope is in very good shape. All systems are nominal, no problems to report at this time. All's quiet in the Space Telescope Operation Control Center as the operators continue to monitor their terminals and look at the systems and subsystems on the telescope. Operators here are in the process of some routine tape recorder dumps from the telescope to some ground station sites. They're also continuing to do some fixed head star tracker mapping. And in general, just send up regular commands up to the telescope via the low gain antenna. All systems are nominal with the telescope, no problems. No problems to report at this time. This is Hubble Telescope Control in Greenbelt.
This is Mission Control Houston. Planning Shift Flight Director Lee Briscoe has just received an update on the weather forecast from the Spaceflight Meteorology Group here in the Johnson Space Center. And it appears that the frontal system moving through California is moving a bit slower than was forecast, and that it may not pass through the Edwards area until midday Sunday. Current conditions at runway 23 are winds of 12 knots gusting to 18 knots out of 251 degrees. It makes the picture for landing a little bit brighter with the front apparently slowing down. With perhaps lighter winds than were previously forecast in the evening. This is Mission Control Houston at 4 days, 16 hours, 27 minutes mission elapsed time. We're now about a half an hour away from awakening the crew of STS-31. That event will occur at 12:34 a.m. Central Daylight Time. That will be a wake-up for them on the day they return to Earth. They're scheduled to land at Edwards Air Force Base at 8:49 a.m. Central Daylight Time today. The weather forecast for that landing opportunity has been improving during the night. A recent update to the flight controllers here said that the front that's been moving through California and causing some problems or forecasts for some strong winds tomorrow morning at Edwards has apparently slowed somewhat. Right now it is passing through the San Francisco area. Winds at Edwards runway 23 at present are 12 knots gusting to 18 knots out of the west. That has dropped considerably from earlier in the evening when real-time data had shown that winds were 22 knots gusting to 35 knots at the runway. Current predictions are that the front might not pass through the Edwards area until after our second opportunity to land tomorrow, which means it will not go through there until after 11 a.m. Central Time. And if that is the case, then winds will be much lighter than previously predicted. Forecasts earlier in the evening had shown winds to be 18 knots gusting to 25 knots. However, now that appears that it'll be much lighter and we will be much more inside our limits for landing than previously forecast. At 4 days, 16 hours, 29 minutes mission elapsed time, this is Mission Control. This is Mission Control Houston. Updates on the weather at Edwards are continuing to come in. On the right-hand screen, on the right-hand side of the global tracking map in the front of the room is a readout of wind speeds at Edwards runway from towers located on those runways from about 12:10 a.m. local time. And winds at runway 23 have continued to drop and now are 9 knots gusting to 12 knots, still from the west. Although those winds are dropping, they're expected to increase as we approach landing time, however, not quite as strong as was previously forecast. Again, our next television event will be the awakening of the STS-31 crew. That will occur at 12:34 a.m. Central Daylight Time, about 12 minutes, or 4 days, 17 hours even mission elapsed time. It's been a quiet night for Discovery. No systems problems have been spotted overnight by controllers here in Mission Control. Most of the night's activities have concentrated on keeping an eye on the weather in California. Discovery prepares for re-entry today.
Rise with the bluebird shine, like the sun.
Good morning, Discovery. Your morning mail is on the way. We have no more immediate messages for you. Have a good breakfast, and we'll talk to you later.
Morning, Houston. Thank you.
We conducted a poll on board KT, and we want to know if the flight director selected that music.
We're trying to decide how to answer that. He did approve that music, I'll give you that.
Maybe that explains what's been happening to the Marvel.
This is Mission Control Houston. The crew of Discovery was awakened for their final day in space, the day that they will return to Earth, with the song Rise and Shine, off of an album by the same name, performed by the group Raffi with Ken Whiteley. The album is on A&M Records.
Houston Discovery.
Go ahead, Discovery.
Roger, taking a look at the tags, I do not see a jam overtemp light on. Are you happy with its condition?
Stand by one, Bruce.
Okay, I guess basically what I'm driving at, and there's no rush, are we going to deactivate it at our convenience, or do you want to wait for some specific time?
Stand by one, Bruce. Discovery Houston for Bruce. We have the deact scheduled in the timeline for today, and we still want to do some more looking at it. So we'd like for you to do it per the timeline.
Okay, I copy. Thank you.
This is Mission Control Houston. The text and graphics system referred to in that exchange between Mission Specialist Bruce McCandless and Spacecraft Communicator Kathy Thornton had been left powered on during the night so that the Integrated Communications Officer could remotely operate it and attempt to duplicate problems which it had experienced earlier in the flight. Under the normal flight plan, the text and graphics systems would have been deactivated in preparation for entry yesterday. However, it was left on so that it could be attempted to duplicate that problem.
Discovery Houston, we may have had a data dropout when we were transmitting message 51, the mission summary. If you have a problem with us, let us know and we'll send it up again.
Roger, Kathy. We'll take a look at it.
The morning mail was sent to Discovery using the teleprinter this morning and not the text and graphics system. It can only be used for communications when the orbiter's KU band antenna is deployed, and that was stowed yesterday in preparation for entry. However, it can be left on and remotely operated, although not used for communications, as it was during last night.
Discovery Houston, for Bruce or whoever's near the tags, we'd like for you to check and see if you see a page in the tray, and then we'd like for you to power cycle the tags, please.
That's in one. Okay, Houston.
Discovery Houston, you're breaking up. We lost that transmission. Say again.
Okay, there is not. It is negative on a page in the tags, and I understand you want me to power cycle it with the regular power switch.
That's affirmative, Bruce.
Okay, coming off on my mark. Going back on, mark. When
Okay,
it came back on, I briefly got the overtemp light. Now the gem.
Okay, thanks, Bruce.
Before we power it down, I would like to advance and get one page out. I have a theory that leaving a piece of paper sitting there for 8 or 10 hours is causing a dark spot, which may be confusing some of the sensors. I'd like to get at least one sheet out and see if it holds up.
Okay, Bruce, you have a go for that.
Okay. And KT on the teleprinter, the last message we have on board is 50 Alpha, over, not, it's 50 Alpha.
Bruce, that's the last message we sent. 51 should have come before then.
Houston Discovery, message 51 Alpha. Looks at first glance like it's complete. We've got 3 pages. If we find anything that is missing, we'll call you later, but there are no garbles.
Okay, you may have a row or 2 of stars, but if it looks okay to you, that's all right with us.
And I've got my page out of the tags, and it has a black spot about 1 inch back, maybe an inch and a quarter back from the leading edge of the paper near the center, just like the other sheets did that were the first ones to come out after sitting for a prolonged period of time with no message traffic. Over.
Okay, we copy that, Bruce. Thanks. Discovery Houston, we're a minute to LOS. Pick you up on the other side at 1725.
1725. See you there, KT.
This is Mission Control Houston. We've lost communications with Discovery as it passes out of range of the Eastern Tracking Satellite. In the minutes preceding this loss of signal, conversation between Mission Specialist Bruce McCandless and Kathy Thornton concerning the text and graphics system was referring to commands that the Integrated Communications Officer had sent to that system overnight. It cannot be used for communications for sending actual pages and messages when the KU band is stowed. However, it can be remotely commanded. And over the night, the Integrated Communications Officer had tried to send page advance commands to advance blank pages through the system. The test was to try to duplicate a problem seen with the text and graphics system on flight day 3, when messages could not be sent up until after crew wake up and after the crew had advanced pages manually. And no pages did advance. However, a theory by Mission Specialist Bruce McCandless that a sensor was causing an overexpose of the page that stayed in the text and graphics system for a long time apparently was proved well. when he did advance a page and found a problem with it. Everything on board the spacecraft has been functioning well overnight as the planning shift has watched the systems while the crew slept. The members of the entry team are in the control center now and preparing to go through a briefing prior to taking over responsibilities for Discovery as it returns to Earth. At 4 days, 17 hours, 21 minutes mission elapsed time, this is Mission Control, Houston.
Discovery Houston, we're back with you on the west.
Okay, Kathy, we're loud and clear with you.
Discovery Houston, we see good stars in the table. Your go to align to those stars and cancel the IMU maneuver. Stay where we are right now.
Okay, we copy. Thanks, KT.
Houston Discovery.
Go ahead, Discovery.
Okay, if Eclipse is there, we're ready for the cryo OT tank heater sensor check.
Okay, we're watching that, Charlie.
Okay, KT, the sensor check's complete.
Okay, thanks, Charlie.
This is Mission Control Houston. Our next scheduled television event, the change of shift briefing with planning shift flight director Lee Briscoe, has been canceled. Again, the change of shift briefing with off-going planning shift flight director Lee Briscoe has been canceled.
Discovery Houston, I have a couple personal notes before I turn you over to your entry team. For Kathy, Mr. Bill and Colleen have invited you over for pizza. That offer is good tonight only. And in the Navy blue and gold game, Shea Bolden made the catch of the day. Navy won that game.
Okay, we copy. We'll see if there's any replies.
And KT, you might tell Mr. Bill and Colleen that I am asking Dr. Hawley and Mr. Bolden for permission.
I'll pass that along.
May have something to do with this.
Maybe we can rustle some pizza for them too.
And for Shea Bolden, if you can get word up there, tell him that's spectacular. That's the best news I've heard all week, unless you guys let us come home today.
And we're working real hard on that. We're going to turn you over to your entry team, and they're the guys who are going to bring you home. We'll see you at Ellington this afternoon.
Thank you, Kathy. We sure appreciate all the fine work you and Lee and the guys did looking over us.
We enjoyed it. We'll see you this afternoon.
We hope so.
This is Mission Control. The change of shift briefing with off-going Flight Director Lee Briscoe has been canceled. Please note that the change of shift briefing with Planning Team Flight Director Lee Briscoe has been canceled.
Houston Discovery.
Go ahead, Discovery.
Okay, I've got PCG deactivation report here if you're ready to copy.
That's affirmative. Go ahead, Bruce.
Okay, commence deactivation at 04 days, 17 hours, 25 minutes MET with a rim temperature of 21.4 degrees centigrade. The METs for each tray, top tray, 1728, seating tray, 1729, bottom tray, 1730. The following are the syringe assemblies that I did not plug. That is, I pulled the toggles and did not plug them. India 4, because there's a significant amount of grease or material visible on the end of the syringe. Hotel 2, There's a big crystal plus some liquid on the divider between the two halves of the syringe. Papa 2, I previously mentioned not plugging. Echo 7, all of the echo proteins had a lot of crust-type material around the rim of the syringes, so I sort of arbitrarily picked Echo 7 to leave uncapped so the guy can see what I'm talking about. Kilo 3, it has a big, oddly shaped crystal in the form of a plate with a tip projecting out beyond the end of the syringe. I decided not to plug it to avoid putting undue mechanical stress on the crystal by pushing it back in. That's it for the not plugs. Rim temperature of 21.1 degrees C at the conclusion. Concluded at MET of 4 days, 18 hours, 21 minutes, and made up a micro cassette voice tape 23 alpha while I was working along on that. Over. We decided that in order to avoid the uncertainty involved in getting the orbit taken care of, that we'd advance this a little bit and get it out of the way so we could go ahead with the rest of the activities.
Okay, Bruce, thank you for the report. It all sounds good, and payload folks appreciate it.
Okay, I guess it's about 2 in the morning down there, so there's probably not a great deal of attentivity.
Well, it's still a little sleepy around here, but we're getting there, Bruce.
Roger, roger.
This is Mission Control. Mission Specialist Bruce McCandless read down a fairly detailed report on the protein crystal growth, a secondary experiment carried in one of the mid-deck lockers aboard Discovery. That experiment has now been deactivated as the crew continues their preparations for deorbit and landing later this morning. This is Mission Control at mission elapsed time 4 days, 18 hours, and 53 minutes. We're getting ready to hand over the video part of our satellite transmission capability to Dryden Flight Research Facility for a weather briefing. And we will be giving up the video capability on our satellite there for about an hour. We will still have audio capability, however. It's fairly quiet in Mission Control Room as flight controllers continue their planning for this morning's entry and landing. Crew reports no problems aboard Discovery, and in fact the air-to-ground traffic has been minimal so far since the crew woke up about 2 hours ago. This is Mission Control.
Houston Discovery.
Go ahead, Discovery.
Roger, we have message 55 Charlie on board, 1 page.
Roger that. That sounds good. That's what we sent you on.
This is Mission Control. We've gone out of range of the Tracking Data Relay Satellite East, and we'll reacquire in about 5 minutes through the Western satellite. Crew should be about to do the 2 medical detail secondary objectives this morning on their timeline. That one is the central venous pressure measurement, and the other is the intraocular pressure measurement. Both of these DSOs have been done on previous missions, and the data is compared to that we've already taken, and we'll be continuing these studies on other missions as well. Flight control team will be getting a weather briefing beginning about 10 minutes from now from forecasters at Dryden and our weather people here at JSC as well. Current conditions at runway 23 show the wind presently on the runway gusting from 29 to 35 knots. The steady state crosswind component is crosswind from the right at 10 knots and a 27 knot headwind. Those measurements were taken about 10 minutes ago at 12:30 a.m. Pacific time.